GM's Exhibit 0. We are proud to be part of a reimagined CES and to connect with people more than ever before. We want to use this moment as an opportunity to look forward with optimism and hope. But first, I want to look back. Because many of us have arrived at this moment tired and wearied by this past year. We see optimism in the vaccines being distributed around the world. But when we reflect on 2020, for many, it will be with sadness and frustration. This time last year, there was reason for optimism. A collective belief in the indisputable science behind climate change was prompting companies to make unprecedented commitments toward reducing carbon emissions. Investors were asking companies to put purpose alongside profit to unlock long-term value. But the coronavirus was starting to spread. As a global company, we tracked its movements, starting in China and then around the world. Our priority was the safety of our employees and our customers. We put protocols in place for our employees, and we worked closely with dealers to support online sales and enhance cleaning procedures so they could continue to serve our customers. And just as North America was shutting down, we saw the opportunity to do more. One of General Motors' greatest advantages is our manufacturing expertise and scale. So we came together with ventilator manufacturer Ventec Life Systems. And within 30 days, we had started production of 30,000 critical care ventilators at our Kokomo facility in Indiana. We also used our resources and scale to make and deliver 200 million and counting face masks and other personal protective equipment for frontline workers. The General Motors team showed what is possible with purpose and the will to take action. But in the midst of all of this, George Floyd, Ahmaud Arbery, and Breonna Taylor became 3 more names on the growing list of Black Americans who have lost their lives based on the color of their skin. I expressed at that time my impatience and disgust with the fact that the nation seemed to be placated by asking why this happened instead of what are we going to do to drive meaningful and deliberate change. I owe my role as CEO to GM's legacy of inclusion, but we knew we could do better, and we would. We announced our intention to be the most inclusive company in the world. We encouraged uncomfortable conversations with our own employees. We started an inclusion advisory board. We allocated $10 million for organizations fighting racism, bigotry, discrimination, and hatred, which have no place in our world. We took action, as did many others around us. And for all the tragedy and heartache and loss, this is what General Motors wants 2020 to be, a call to action. Because while we are weary and while there is hope, the battle isn't over. The health crisis, racial injustice, and climate change persist, and so we must persist. At General Motors, our vision for the future is a world with 0 crashes, 0 emissions, and 0 congestion. The key to unlock that vision is electrification. The electrification of global transportation can help reduce emissions, empower the advanced systems and connectivity between vehicles and transportation infrastructure to help reduce congestion and crashes. General Motors pioneered vehicle electrification 25 years ago and introduced the world's first affordable long-range EV, the Chevrolet Bolt, right here at CES. But global EV market penetration stands around 3%. We believe that is all about to change. At GM, we believe that after one of the most difficult years in recent history, this moment will prove to be an inflection point. The moment when our world's reliance on gas and diesel-powered vehicles will begin transitioning to an all-electric future. And GM intends to lead that change, not only to help accelerate the rollout of more electric vehicles, but to help ensure an equitable and inclusive transition to a net zero carbon future, to advance a safer world for all. We believe we have the technology, the talent, and the ambition to deliver on that commitment, to challenge perceptions, inspire drivers, and lead the world into a new era. We are repositioning General Motors to meet this moment as our company has rallied to meet so many moments before, to signal the start of a new chapter in our history. We're evolving our brand identity and launching a campaign intended to inspire a new generation of drivers, setting a tone of optimism and inclusion. And where GM forges a path, Chevrolet, GMC, Cadillac, and Buick will follow with electric vehicles and experiences that help put everyone in an EV. Over the course of this presentation, we will share the reasons why we feel so much confidence and optimism, starting with the advances in technology that are helping accelerate our vision and the GM Ultium platform.
Ultium is the world's first hyperscale electrical vehicle platform with the power to make almost any vehicle an electric vehicle. A combination of groundbreaking battery architecture, highly flexible electrical propulsion systems, and a common high-energy battery cell that will power an entire range of next-generation electrical vehicles. It all starts with the battery chemistry. Lithium-ion batteries typically use a blend of nickel, manganese, and cobalt to produce reliable power. Ultium's battery chemistry reduces reliance on cobalt by 70% through adding alumina. This reduction in cost also addresses the challenges of sourcing sufficient cobalt to match the growth in demand as the number of EVs on the road increases. The foundation of our platform approach is a single common cell design that can be used across all our vehicles. This will be the best large format cells in the industry, optimized to provide sufficient power for multiple vehicle designs. And we manufacture those cells in-house as part of a joint venture with LG Chem. The cells will produce 60% more energy capacity than our existing electrical battery cells, and use a flat rectangular pouch design that reduces the space between cells and can be stacked more efficiently into modules for higher energy density in a smaller space. Vertical stacking of cells within modules helps us build trucks, SUVs, and large crossovers. Horizontal stacking enables low-slung performance vehicles. And in between, we have the platform for mid-size and compact crossovers. The modules themselves are state-of-the-art, using 19% less wiring than our current batteries to communicate between the cells, increasing the amount of power available per square inch. General Motors will be the first automaker to use an almost completely wireless battery management system for its production electric vehicles. The system monitors and balances the cell chemistry on a constant basis, ensuring optimum performance and charging capacity. Finally, the modules are placed into the vehicle's battery pack, a structured enclosure which doubles as part of the vehicle's chassis and protects the cell from damage in the event of a crash. We can use 6, 8, 10, or double stack up to 24 modules in a single pack, depending on the power requirements of the vehicle. The end result of all these innovations is a battery that will produce up to 450 miles of range on a single charge, and nearly 40% less cost and 25% less weight than our current EV batteries. We'll combine all these innovations with an incredibly flexible propulsion system called Ultium Drive, which uses 5 interchangeable drive units to deliver front, rear, or all-wheel drive from a single system. The Ultium platform is a breakthrough in electric vehicle technology. And we are not finished. We are working on our next-gen high-energy battery chemistry that will reduce the reliance on cobalt and nickel even further, while reducing cost by 60% compared to the current batteries. We estimate these lithium metal batteries will deliver twice the energy density of even the Ultium battery cell, providing 500 to 600 mile range on a single charge. Once you have the power, you have to distribute that power to the vehicle's internal system. Modern electric vehicles are not only electrical propulsion system, they contain many advanced technologies like driver assist features that draw on the vehicle's electrical bandwidth. GM's vehicle intelligence platform provides the software enabling layer that keeps everything working. It is a new, innovative, digital electrical architecture that provides more rapid communications between the vehicle's system and to the outside world, and is capable of managing 4.5 terabyte data processing power per hour, a 5-fold increase in capability over GM's current electrical architecture. VIP will serve as the software foundation for our EV ambitions and will be integrated into nearly every GM vehicle globally by 2023. We are incredibly excited by the possibility Ultium and the VIP provide to General Motors, not only in terms of converting our existing vehicles to all electric, but in terms of new capabilities in vehicle performance and customer experience.
As May said, the opportunities presented by advancements in technology are enormous. The mass adoption of electric vehicles will be a transformative moment in our history. But for most drivers, it will be an entirely new experience. We want to reimagine the whole concept of vehicle ownership and driving. And we're calling that reimagined experience Ultify. Ultify is a promise of a more personal EV experience, putting you in control. A single unified platform that simplifies discovery, education and management of your GM products and services, making it easier for you to explore EV options like make a reservation, get transparent pricing, purchase a vehicle online, or visit a local dealer to complete your purchase in person. It will provide owners with a unique customer ID they can use to set up an online account, set preferences, book a service, or make additional purchases. The Vehicle Intelligence Platform gives us the ability to deliver over-the-air updates to your vehicle. You should expect both ongoing free updates as well as opportunities to purchase premium content and feature upgrades, as well as personalisation options, media streaming services and third-party applications. And at the centre of it all will be the all-new mobile app experiences. My Cadillac, My Chevrolet, My GMC and My Buick, all coming in spring. These apps provide a remote control for your vehicle that will continually evolve and advance over time. You will be able to view your account, manage payments and collect rewards all right from the app. And the new family sharing feature will provide access to the vehicle for up to 8 family members. Perhaps most importantly for our EV enthusiasts is the Energy tab. It will help new and long-time EV drivers accommodate battery charging more easily into their lifestyle. Our goal is to have your home charging unit installed before you even take possession of your vehicle, so you can plug in your car at night just the same as you do your mobile phone. If you need a quick charge while you're out driving, we'll be able to help you find the nearest charge station, set up a payment and start charging all in the same app. Ultium-powered vehicles charge very quickly. They will provide up to 90 miles in a 10-minute charge, which means you'll be able to easily top up whenever you're on the move. Another way we're reimagining the future of the driving experience to focus more on you, the driver, is via OnStar. OnStar has provided remote services to GM drivers for 25 years. We hear countless stories of OnStar subscribers relying on the button inside their vehicle at some of the most crucial moments in their lives. Today, OnStar receives 150,000 calls a day, more than 6,000 automatic crash response notifications and 120,000 remote vehicle unlock requests every month. And last year, we announced that OnStar was extending its lifeline even further with the introduction of the OnStar Guardian app, which places OnStar services on your mobile phone, providing access to an emergency advisor wherever you are and whoever's car you're driving or riding in, as well as extending services to loved ones for added peace of mind. In addition, and more recently, we announced OnStar Insurance. In the short term, it will make it easy to purchase insurance from GM through the OnStar Insurance services. But in the future, it will leverage the vehicle's OnStar telematics data to personalise insurance premium based on your individual driving behaviour, giving people the ability to directly influence the cost of owning and operating their vehicle. And over time, we will have the ability to integrate automatic crash response with OnStar insurance to help streamline the entire claim process. We have very big plans. As vehicles become more intelligent, more of the focus can turn to occupants and their sense of personal enjoyment, freedom and control. Nowhere is that more evident than with Super Cruise. Super Cruise is the industry's first truly hands-free driving assistance system. It's unique in that it uses a driver attention system to detect if the driver is paying sufficient attention to the road ahead. Now, if not, the steering wheel light bar flashes to prompt the driver to return their attention to the road. The driver attention system makes clear when Super Cruise is engaged and what the driver's responsibilities are. As a result, drivers can more simply integrate to the journey ahead. And once again, thanks to the Vehicle Intelligence Platform, we have the ability to send new Super Cruise features directly to the vehicle via remote software updates. The customer response to Super Cruise has been stunning. 85% of customers driving a Cadillac CT6 said that they would prefer or only consider a vehicle equipped with Super Cruise for any future vehicle purchase. And that's why we're making Super Cruise a much bigger part of the EV experience. We're bringing Super Cruise to 22 GM vehicles by 2023, including Chevrolet Bolt EUV. Chevrolet Bolt EV gave many people their first experience of living with an EV, from quick acceleration to convenient charging at home. And we will continue to reimagine this vehicle with fresh design, more technology and new features. But as we think about the future, we want to build on that strong foundation. The Chevrolet Bolt EUV will share the original Bolt's reputation for fun, functionality and purposeful technology, and will be the first Chevrolet and GM's first EV to feature Super Cruise driving, making one of our most advanced technologies accessible to even more drivers. We're planning to share more details about the Bolt EUV very soon, and we're excited to give more people the option to try Super Cruise. As you can see, we're investing to not only ensure you can drive electric, but you can love driving electric.
All of this advanced technology puts GM in an incredible position to help accelerate the adoption of electric vehicles. We're spending more than $27 billion on our electric and autonomous vehicle programs by 2025. And we feel confident that this emphasis we are placing on a more personalized driving experience will make our future EVs some of the most enjoyable and exciting vehicles we've ever made. Let's take a look at what our design and engineering teams have in store for you.
Whether you're talking about a smartphone, a TV or a car, design is influenced by manufacturing, materials and components. As those elements change, design changes. The start of the EV era represents the most significant change in vehicle design since the 1920s, when GM's first chief designer, Harley Earl, developed the modern concept of vehicle design. Earl pioneered the idea that design could create an emotional connection with the vehicle, and these connections could be as diverse as people's individual tastes. Since then, vehicle technology and manufacturing have come a long way, but those design principles remain the same. Initial electric vehicle designs were intended to signal that this is an EV for people making that choice. Now, as the world prepares to go all electric, we're drawing a line in the sand and rethinking how an entire range of electric vehicles should look and feel. As May demonstrated earlier, Ultium's modularity provides incredible flexibility, with 3 main architectural configurations to be used across Chevrolet, Buick, GMC and Cadillac. We are able to accelerate the design process, helping to deliver a full vehicle lineup in record time. Meanwhile, VIP's electrical bandwidth and connectivity gives designers the power to reimagine the personality of the vehicle in light, colour and sound. Now, over the next 5 years, General Motors will introduce 30 new EVs globally, representing a range of options, whatever your priorities. That includes the refreshed Chevrolet Bolt EV and the new Bolt EUV, both in dealerships by this summer. Chevrolet led the charge, putting more drivers in an EV. The Ultium platform will allow Chevrolet to further expand its range of electric vehicles to full-size pickup trucks, compact crossovers, and even high-performance vehicles. Chevrolet's well-established expertise building vehicles that combine compelling design, useful technology, and performance have resulted in some of GM's best-selling vehicles and will continue to bring more choice and broader adoption of electric vehicle technology to even more drivers. There will also be new vehicles from Buick with a refreshed strategy based on electrification, connectivity, and intelligent driving. Buick is now entering its third decade in China, the world's largest EV market, and will build on the growing popularity in China of the Buick Velite family of electric vehicles with 3 new Ultium-powered EVs, adding a new crossover and SUVs to the lineup, including 2 you see in the distance behind me. And of course, we've already announced new electric vehicles from GMC and Cadillac, the GMC Hummer EV and the Cadillac Lyriq. Today, we want to share more details about those vehicles and to help give some sense of what you can expect from the new lineup of EVs coming from GM over the next 5 years. And we want to reveal details about a vehicle we've never shared before, the Cadillac Celestiq.
A great deal has been said about the GMC Hummer EV since it was first unveiled in October. The irony of introducing Hummer as an EV is not lost on us. This vehicle is the clearest articulation of exactly what we mean when we say any vehicle can be an EV. This is the world's first all-electric super truck. GMC Hummer EV will be capable of 0 to 60 in about 3 seconds with 1,000 horsepower and 11,500 pound-feet of torque. It has a crazy amount of power. It celebrates the performance possibilities of electric propulsion. This is a truck you want to drive because it delivers performance in a way that no other truck can match. And it happens to have 0 emissions. 2 things in particular I want to share with you that we haven't really talked about before. Terrain mode 1-pedal driving and the Bose electric vehicle sound enhancement technology. In terrain mode, the GMC Hummer EV offers 1-pedal driving for precision handling at low speeds while off-roading and rock crawling. It combines the fine control of the immediate torque provided by the EV propulsion system and the friction brakes to deliver a level of modulation that is beyond anything we could deliver from a gas or diesel-powered engine. It is a smooth experience, providing finely modulated power control that can dominate the most difficult terrain. And if you will love the power off-road, wait until you try it on-road. Watts to Freedom mode builds an entire experience around that 0 to 60 sprint. The double press of the traction control button triggers a request to acknowledge you are about to do something special. Acknowledgement causes the vehicle to lower and the battery electronics temperatures to be optimized in preparation for full power delivery. The driver coach tells you to apply the brake as the seat and the subwoofer start to shake. Then you apply the accelerator, and once you reach the required levels, you let the brake go and hold on. I've experienced the thrill of jumping out of a plane at 30,000 feet. In my opinion, this is better. But how do you create the sensory explosion to accompany motors turned up to 11? We worked with Bose. Bose electric vehicle sound enhancement technology makes its debut in the GMC Hummer EV. It incorporates guitar riffs, high-frequency feedback, and inspiration from Formula E motorsports to communicate the sensation of power and torque that you've unlocked in Watts to Freedom. It is a truly immersive sensory experience that brings you in direct contact with your vehicle, and we can't wait to share it with you later this year.
If the GMC Hummer EV is power and dominance, the Cadillac Lyriq is the artful integration of technology for a most intimate driving experience. Introducing our new face of Cadillac, the Lyriq is an uncompromising SUV, the embodiment of Cadillac innovation and a showcase of technologies you will see repeated over future Cadillac EVs. We took advantage of the quiet that comes with the Ultium-powered EVs to curate an entirely new sensory experience, and the inspiration of VIP's electrical bandwidth to reimagine what it means to always be connected to your vehicle. It starts as you approach the Cadillac Lyriq, a layering of technology and choreography of light that draws you inside and makes us very intimately your vehicle. Recognizing its driver, the Lyriq prepares the cabin for the journey and continues that rhythm of light from the exterior to the interior. Once you are inside, you understand what we mean by artful integration. The curved 33-inch diagonal advanced LED display provides a customizable user interface with the capability to display 1 billion colors. We worked with Territory Studios and RightPoint, 2 companies with unique experience in creative strategy, design, and technology to help challenge expectations and bring Cadillac's vision to life. And while we've announced that the GMC Hummer EV will leverage Epic Games' Unreal Engine used to make Fortnite and this keynote, we can announce that we will also be using the technology in the Cadillac Lyriq to bring display information to life in engaging 3D perspective. That layering of technology continues into the dual-plane augmented reality heads-up display that incorporates navigation directly into your field of view. And combined with our next-generation Super Cruise driver assistant technology, helps provide confidence and control. My role at General Motors is lead designer for choreographed experiences in addition to Cadillac lighting. That role did not exist before electrification gave vehicle design the opportunity to rethink our relationship with our vehicles. Now it signals a new future for the interaction of technology and the senses.
If the Cadillac Lyric is the new face of Cadillac innovation, I want to introduce its ultimate expression, the all-new Cadillac Celestiq. Working on the Cadillac Celestiq is a designer's dream. The architecture of the Ultium platform carved out new space and gave us the freedom to integrate more technology. The result is a dramatic presence with a low profile and rearward proportions. Each vehicle offers a curated selection of materials, which are crafted by hand for the ultimate luxury experience. And with all-wheel drive, four-wheel steering, and a full glass roof, it celebrates the extraordinary. Cadillac Celestiq extends the artful integration of technology you already saw in the Lyric, but reaches new heights. That roof will be our first to feature 4-quadrant suspended particle device smart glass, allowing each occupant of the vehicle to set their own level of transparency, while the tint of the glass colors to match the ambiance and the mood of the interior. That equal and individual experience for each occupant will be a signature aspect of the Cadillac Celestiq. The driver and front seat passenger enjoy a pillar-to-pillar display that brings the outside inside, while rear seat passengers have personalized entertainment screens with active privacy, and console screens that separate individualized comfort settings from entertainment displays to minimize distractions. Cadillac Celestiq represents the artful integration of technology to reimagine what it means to be a passenger. We can't wait to reveal more soon.
Hopefully, the GMC Hummer EV, Cadillac Lyric, and the Cadillac Celestiq, along with the Chevrolet Bolt EUV that Travis announced earlier, gives you some sense of how we're approaching this new chapter in GM's history. The layering of technologies to create sensory and emotional connections, which immerse the occupants in the distinct purpose and personality of that vehicle. Whether that's the power of the GMC Hummer EV or the luxury of the Cadillacs, each vehicle represents a bespoke and curated experience. And as technology continues to evolve, we intend to continue this design trajectory, delivering experiences that reflect the possibilities and the probabilities of future transportation. Now let me introduce you to the Cadillac Halo portfolio. This is a design concept that provides a social space for a group of friends or family to spend time together on their way to a destination. The vertical light signature is choreographed to greet and draw passengers inside. The expansive glass roof keeps the group connected to the outside, but encourages eyes to turn inside to focus on one another and personal well-being. Biometric sensors read passengers' vital signs to adjust temperature, humidity, lighting, ambient noise, and even aromatics for optimal comfort, while voice control and hand gesture recognition makes adjusting the interior effortless. It's a space for sitting back, relaxing, and arriving in style. The vertical takeoff and landing drone, or VTOL, is GM's first foray into aerial mobility. We are preparing for a world where advances in electric and autonomous technology make personal air travel possible. It is a concept designed for the moment when time is of essence and convenience is everything. You've been at the office and now you need to get to a meeting across town. The VTOL meets you on the roof and drops you at the vertiport closest to your destination. It uses a 90 kilowatt-hour EV motor to power 4 rotors, as well as air-to-air and air-to-ground communications. As a passenger, it represents personal space and a panoramic view of the world passing beneath you, and is a glimpse of what autonomy and Cadillac luxury might look like in the not-too-distant future. We have other concepts coming, including a luxurious 2-seater designed for you and someone very special, to decompress, relax, and enjoy a multi-sensory experience choreographed for more intimate journeys. Each concept reflecting the needs and wants of the passengers at a particular moment in time, and GM's vision of the future of transportation. This is a special moment for General Motors as we reimagine the future of personal transportation for the next 5 years and beyond, leveraging technology to create a consistent GM brand promise, while also delivering an unrivaled range of electric vehicles across our brands, each with unique personalities that reflect the unique priorities of the millions of customers we serve. Even if you've never considered driving an EV before, over the next 5 years, GMC, Cadillac, Buick and Chevrolet intend to present you with a vehicle that you'll fall in love with. And there's a good chance it will be an EV.
We hope by now that you are starting to see how we intend to deliver on our vision of zero emissions. Not just by making zero-emission vehicles, but by using the transition to an all-electric vehicle future as an opportunity to reimagine how we move, making our EV future something people race toward. But we're not stopping there, because this is also an opportunity to reimagine how goods are moved. I'm pleased to announce BrightDrop, a new business from General Motors that reimagines commercial delivery and logistics for an all-electric future. BrightDrop provides an ecosystem of smart, connected products, including electric vehicles and software-enabled services, offering commercial delivery companies a platform for sustainable growth. Families manage a few cars at a time. Delivery companies manage thousands, even hundreds of thousands of vehicles. They are on the front lines of efforts to reduce vehicle emissions and congestion, as many countries around the world set limits on commercial delivery vehicles, while at the same time trying to meet rapidly rising demand for e-commerce services. That means processing millions of packages coming from an increasingly diverse number of businesses, while meeting changing expectations about how long people are willing to wait for those packages to reach their door. The pandemic has only accelerated those challenges, as this sector became our lifeline to goods and services we could no longer access in person. BrightDrop represents an all-new approach with a dedicated platform leveraging Ultium to provide precisely what our customers are asking for. It aims to provide this sector with products, software, and services, as well as support that they need to move goods, from warehouse shelf to front door, as efficiently and safely as possible.
BrightDrop's goal is to transform delivery and logistics for an all-electric future. It includes an expanding range of connected, all-electric products and the tools and services to make those products work together efficiently, intelligently, and all with less impact on the environment. It starts with the BrightDrop EP1, an electric-propelled pallet that helps reduce the time and physical effort required for couriers to get goods from the delivery van to the front door. Goods are consolidated and loaded into the EP1 at the warehouse based on their destination. The BrightDrop mobile asset management platform connects to the EP1s, so key information like location, battery status, and more can be viewed remotely. The EP1's electric motor makes it easier for couriers to move around. Its speed adjusts up to 3 miles per hour, depending on the courier's walking pace. The pallets are purpose-designed for optimal loading into delivery vehicles and can be tethered together for larger drops, helping to reduce errors, secure packages, reduce the strain on drivers, and enable more efficient delivery. Don't be surprised to see couriers leading EP1s down our sidewalks in the next few months. Then, of course, we have the all-new BrightDrop EV600 electric van. The BrightDrop EV600 will be built on the Ultium platform using the same high-energy modular architecture and is targeted to provide up to 250 miles of range while optimizing available cargo space. It's lightweight, purpose-built to carry BrightDrop EP1s. It has segment-leading active safety features and zero emissions. It will also be part of the connected family of BrightDrop products, which delivery companies can manage remotely via our BrightDrop fleet management platform to help optimize vehicle use and oversee energy management. The first EV600s will be delivered towards the end of this year. The BrightDrop integrated ecosystem will leverage a combination of BrightDrop's sales and service network, as well as a newly established BrightDrop dealer network for sales and service support for the EV600s. And the BrightDrop EP1 and EV600 are just the first of an expanding range of products that will connect seamlessly for increasing efficiency. A number of BrightDrop concepts are being explored, such as a medium-distance solution that transports multiple EP1s, and a rapid load delivery concept designed to load and unload EP1s on and off the vehicle with ease, freeing up valuable curb space quickly. And just like our consumer vehicles, we're committed to help make the transition to a smarter, all-electric future as easy as possible. To support these products and services, we will help customers set up charging infrastructure and provide access to parts, service, and more. BrightDrop is a single destination for delivery companies that want to make the transition to a more sustainable future, moving goods more efficiently to help reduce congestion and lower emissions, helping electrify an industry.
BrightDrop is the result of working with commercial customers, listening to their challenges, and leveraging our technology to help meet their needs. To further innovation, BrightDrop has partnered with another iconic American company and a global leader of express distribution, FedEx Express. I've asked Richard Smith of FedEx Express to tell you more.
Thanks, Mary. FedEx has spent the last several years implementing innovative solutions to prepare our business for the exponential growth in e-commerce. That forward-looking effort really paid off for our customers during the pandemic. In the last 9 months, we've seen e-commerce accelerate to levels that weren't anticipated for another 3 to 5 years. And as people have experienced the ease with which they can now get an incredible range of goods delivered directly to their doors, we don't expect them to go back when the pandemic is over. To put it into context, we expect U.S. residential deliveries to reach 100 million packages a day by 2023, which is 3 years earlier than previously estimated. We also continue to see growth in the need for express, time-definite delivery in industries like healthcare, technology, and aerospace and automotive manufacturing. Right now, we are shipping hundreds of thousands of doses, and soon to be millions, of COVID-19 vaccines through our express network. So our need for reliable, sustainable transportation has never been more important. BrightDrop is a perfect example of the innovations we are adopting to continue to transform our company. BrightDrop products will help FedEx Express handle unprecedented demand, improve the safety, security, and timeliness of deliveries, reduce our environmental impact, and protect the well-being of our couriers. In an initial pilot we ran with the BrightDrop EP1, our FedEx Express couriers were able to effectively and safely handle 25% more packages per day. The feedback from our team members has been excellent. The EP1s were easy to maneuver and helped to reduce physical strain. We're so pleased we have a second EP1 pilot planned to take place this quarter, and we're expecting the results to be even more impactful. We are also planning to add to our existing electric vehicle fleet by partnering with BrightDrop to introduce the EV600s to our lineup. We are the first company slated to receive the EV600, pictured here behind me, and plan to expand upon that initial commitment to rapidly adopt electricity as a vehicle fuel for years to come. It's part of our FedEx EarthSmart program and our sustainability strategy of reduce, replace, and revolutionize. In this, it does all three, especially revolutionizing for a future with less emissions. And it is consistent with our role of connecting people and possibilities around the world responsibly and resourcefully. We believe BrightDrop will allow for improvements in efficiency at scale, lowering operational costs per mile while improving services for our customers. And, of course, solve real issues around emissions and congestion.
Thanks, Richard. This is just the beginning of what FedEx Express and BrightDrop will do together. And I couldn't be more optimistic for the strides we will take to build a smarter, more sustainable future for the delivery industry. As BrightDrop demonstrates, and as you saw with the GMC Hummer EV, the Cadillac Lyriq, and the Cadillac Celestiq, electrification will be a catalyst for a range of new experiences, and that includes how autonomous vehicles will transform our daily experience. Leading the charge on autonomous vehicle development is Cruise, the self-driving startup backed by General Motors. After years of development, Cruise now has reached the point where it has removed the human driver from behind the wheel, the true benchmark of a self-driving car. and is now testing fully driverless cars on the streets of San Francisco. I've asked Cruise co-founder Kyle Vogt to give you an update on the incredible progress made by Cruise while the pandemic has been raging all around us.
Hi, Mary. Thanks for having me. This is going to be fun. I'm going to start by talking a little bit about what we accomplished in 2020, despite the pandemic, and then what you can expect from us in 2021 and years to come. So if you roll back the clock to the very beginning of the year, we unveiled the Cruise Origin, which was our first purpose-built all-electric autonomous vehicle for the rideshare and also delivery businesses. And that was great because it gave us a chance to show the world the vehicle and the platform on which our technology is going to be deployed at scale to unlock all the great benefits of autonomous vehicle technology. And after that, we announced that this vehicle, Cruise Origin, is going to be built at Factory Zero, which is GM's plant dedicated to building vehicles powered by Ultium battery technology. And that's important to us because we're not really interested by the potential impact that a couple hundred vehicles can have in one city. That's nice, and even if those vehicles are doing great things. But what matters to us at Cruise and for our mission is to use Factory Zero to build tens of thousands or even hundreds of thousands of Cruise Origins so that all those vehicles can be out there touching people's lives with a form of transportation that's safer and more affordable and more accessible. And so that's what we're looking forward to with Factory Zero. And then, of course, later in the year, roll the clock forward a little bit and the pandemic hit. We took a look at ourselves and the company and thought about what we could do. And we decided to repurpose our fleet to deliver food for communities in need in San Francisco. And so we found two local organizations, the SF Marin Food Bank and SF New Deal, and repurposed our fleet to do deliveries. And to date, we've done over 140,000 meal deliveries. And that's awesome. That makes us feel really good at Cruise. And even though that's a big number, we know it's just the tip of the iceberg for the potential impact the positive impact autonomous vehicles can have on our communities. Then a little bit later in the year, we announced our partnership with Walmart, the world's largest retailer, to do a pilot of grocery delivery in Scottsdale, Arizona. And that shows the versatility of the technology we're building and also one of the primary uses of the Cruise Origin when we start to produce that at scale. Then later on, we had a really important milestone both for Cruise and the industry, and also for me personally, which is our first fully autonomous drive with no human backup driver, nobody behind the wheel, on the streets of San Francisco. And that was a big deal. Even though our cars are driving around San Francisco all the time without anyone touching the wheel, doing it with no human backup driver meant that we had done all the validation, testing, legal, lots more testing work to make sure that we had a product that was safe to deploy. And that was in no small part due to our partnership with GM and the 5 months of testing and trial runs that we did at the Milford Proving Grounds. So thank you, GM. That was really great. And of course, all throughout the year, we used our fleet of electric autonomous vehicles, to collect hundreds of thousands of miles of autonomous driving. And that's useful not just for the data that helps us train our AI or for the providing feedback for our engineering teams, but also to give a sense of how the general public and other drivers and our potential customers are going to react to autonomous vehicle technology. And that's really important as we look forward to 2021 and beyond when we do early commercialization of this technology. And as you might expect, we still have plenty of work to do until any of you can ride in a Cruise Origin whenever you want. But in 2020, we burned down a lot of the big technical and scientific and engineering work and risks that could have held us back. And as you know, our mission is not just to build self-driving car technology or build a self-driving car. It's to build a form of transportation that's safer, cleaner, and more affordable and more accessible than what exists today. And we're on the verge of doing that thanks to our partnership with GM, of course, many years in the making. So many more good things to come. And as I look to 2021 and beyond, specifically in 2021, you're going to see our product become more tangible, more visible. Some of you might get to use it. And we're really, really excited to bring all of you along with us on that journey. So thank you.
I hope that what we've shared with you today gives you the same confidence and excitement about our future of electric and autonomous vehicles that we all share at General Motors. Confidence that the pieces are now in place, and excitement for the prospect of a world that is more personal, moves better, and contains experiences none of us have ever had before. And all of us will be able to enjoy. And there's that important word, all. Because if this ambition, talent, and technology doesn't add up to a safer world for all, then it isn't better. We want everyone to have the opportunity to join us and join the movement. We want young girls of color who want to be software technicians or EV and AV engineers to know they have a future at General Motors. We want everyone to have the opportunity to drive the vehicles we're building. And we want every community to benefit from safer, quieter, greener streets. Last year, the Business Roundtable created a special board committee on racial equity and justice. The Business Roundtable is a nonprofit association whose members are CEOs of major U.S. companies. As part of the effort to address ongoing racial inequities in the United States, I was asked to lead a special subcommittee focused on reconciling disparities in education and workforce. Inequities in education disproportionately affect many low-income and minority communities, which can put children from these communities at a disadvantage as early as grade 3. One thing I've learned through my work with the Business Roundtable: before third grade, we learn to read. After third grade, we read to learn. If we're not helping address learning disadvantages early in life, we're setting children up for workforce disadvantages for the rest of their lives. The school closures that have impacted millions of children around the world as a result of the pandemic have exacerbated these problems, creating a potential crisis in the lives and livelihoods of future generations. So as part of advancing a safer world for all, General Motors is donating $1 million to the Khan Academy, one of the world's leaders in online learning, to further its work in bringing best-in-class education to everyone, providing training for educators to help adapt to remote learning, translating existing resources to Spanish and bringing them to Spanish-speaking communities, further aligning distance learning resources across more school districts, creating a new STEM curriculum for students in the second grade, and providing teachers with data-driven, real-time feedback to meet students where they are and bring them up to the standards required in their grades. It is a very proud moment for me to stand here today, representing 164,000 General Motors employees, at an inflection point for our company's history and an inflection point for our society. I hope you've heard enough to join us. Thank you for your time, and please stay safe.
Welcome back to our live coverage of CES 2021. I'm Greg Migliori, editor-in-chief of Autoblog, and we're leading off today with big news out of General Motors. CEO Mary Barra outlines an ambitious plan transitioning the 113-year-old automaker to an electric future. Joining me today to discuss all of this is Tim Grew, Director of Battery Cell Technology and Strategy for General Motors, and John Snyder, Senior Editor for Autoblog Green. Thanks for being with us this morning, guys. Lots of things to unpack, many new initiatives for General Motors. Tim, let's start with you. A big part of the future for GM will be this transition to electric vehicles, and that all starts with batteries, of course. So many different things we saw, from Cadillacs to the new Hummer to delivery vehicles, that are all going to essentially boil down to the batteries. Ultium is sort of the big phrase that we're hearing from Ms. Barra, and I think it's a really cool sounding word that I think can get people excited about electric vehicles and the technologies that underpin them. Could you sort of tell us, maybe get into and explain how these batteries can be scaled and used for different purposes?
Yeah, thanks for having me today. I really appreciate being here. It all starts with the battery chemistry and the battery cell. And we've got a joint venture going with LG Chem, where we bring the best of both companies together to make the world's best battery, where we can use it on a small crossover or all the way up to that EV600, like delivery. And what you do when you have this scalability and this capability to meet all these different customer needs is you can hold your quality, you can hold your cost, and then most important with this architecture, you can upgrade it in the future. And those upgrades will come naturally because we haven't found the bottom of the cost curve yet, and we're still innovating in production through development, and then we have some great R&D breakthroughs that we're going to be able to upgrade into this vehicle whenever they become available.
That's exciting news. Now, John, I want to bring you in, as you're obviously sort of our green expert here at Autoblog. It really seems like, with the onset of electrification becoming more and more mainstream, companies like General Motors can really elevate the conversation and bring electrification to the masses. I know it was almost a year ago now, you got to tour some of GM's battery development and technology at their tech center out in Warren, and we're seeing a lot of these things come to fruition now today with the keynote speech at CES. What are your big takeaways just from this morning's announcements?
Well, it's really interesting. I got to see a lot of these vehicles in person, and some of them are very impressive. The Cadillac Lyriq and Celestiq are beautiful, beautiful vehicles. And just to see that this Ultium battery technology is so modular and able to apply to anything from small vehicles all the way up to the Hummer with 1,000 horsepower is really impressive. What GM can bring to the table with this new battery technology, especially with its modularity and its energy density. Tim, you mentioned GM mentions the addition of aluminum helping to improve the efficiency. It sounds like such a simple thing. How did that come about, and how does aluminum help the chemistry produce these more dense battery packs?
Yeah, so that's a great example of some of the innovation that we had in this Ultium development, where you talk about nickel, cobalt, and manganese, which are fairly widespread throughout the industry. And then what we do is we add an aluminum dopant. Okay, and what this dopant does is it gives you the long life, especially in the high use duty cycle like the EV600. And so you add a small amount of that dopant, and it's sort of like a cladding on the NCA, or on the NCA, nickel, cobalt, and manganese. Sorry about that. I'm getting into industry lingo here. And that improves your life while having your energy density go up a small amount. And that processing is actually very novel. It doesn't add any cost. It just is a good example of how we didn't imagine it 4 years ago when we made the Bolt EV, and now we're introducing it on the Ultium platform.
And let's see, there's another generation of batteries coming after Ultium. Can you tell us a little bit about what that brings to the table. What does that consist of, and how does that work? How are you achieving even greater density and more range?
Yeah, so we call us our innovation cycles. And if I could back off a little bit and explain them a little bit, like when we are in production, we'll never stop innovating. We're always looking for more efficient ways to run the factory and work on the value chain to hit the bottom of this cost curve. The Bolt EV, we went up 10% in energy from 2016 to 2020, and we'll innovate at those levels. The Ultium is what we call our breakthrough technology, where we go to something like an NCMA with that special dopant. We got a 60% bigger cell that we can build all these vehicles with. And we have this modular approach to have that, launch the Hummer with its incredible performance and cars like the EV600. As we have parallel groups working here, they take all that knowledge and all that learning, and they try to take it up to the next level. And so our R&D group, you actually probably saw Mei Kai in the video there. She's one of our scientists out of R&D. And they have developed a protected lithium anode, which basically really puts up the energy density. So you can either go for much higher range vehicles or much smaller batteries in the same vehicle. And she's actually got that working on a multi-cell pouch that you can come and see today. So her team has had a great breakthrough this year in 2020, and I just looked to them to accelerate in 2021. And then when we made Ultium architecture, we made sure that new chemistry can go into those factories, and that new chemistry can go into those cell formats, so we don't have to redesign a Hummer when it becomes available on the next generation. Or when we have this next generation technology, we can launch even more exciting products as we expand this portfolio.
What I think is interesting is the scalability and all the different applications that you guys at General Motors are planning to put electrification to batteries in them. I'm curious, sort of, Tim's question is for you. Why go so all electric? I know there's the theory for some car companies, hey, let's try hybrids for a while. This is definitely a clear stake in the ground saying, hey, we're going to really dial into electric because, we really think that's where the future is going.
Yeah, it's really one of those inflection points. And I think CES kind of brought it back to the real customer facing beyond the technology. And as an engineer, I spent a lot of my time talking about the technology. But even if you look at that previous clip that was just on the screen, where you had those different offerings with a common cell. And so you can drive complexity down, you can reduce your development time, and you can react to whatever the customers want in a much, much quicker way. And when you have that flexibility, you heard some of the designers talk in the video about the options they have, and then you saw some of those electrified interiors. It was just a natural alignment, and we're doing all we can to accelerate into it because we see the technology ready for Ultium, but we don't stop there. We see it further progressing into more and more applications. And so it just is a natural, better vehicle, better customer experience, totally integrated with the technology to have this electrified capability on vehicle.
And we saw recently a crate, basically a crate engine, but electrified, using the Bolt battery platform. And GM put it in a Blazer. And we had a lot of fun with that, picking our own vehicles that we would, retrofit with an EV architecture. With Ultium and its modularity, is there going to be more opportunities for customer retrofit of their own vehicles? Is there going to be an Ultium crate EV powertrain available at some point?
Yeah, it's natural with the technology, and you saw us do it on the Bolt EV. And you can only imagine where we'll go on the Ultium platform. We haven't announced anything at this time, but we have announced multiple other OEMs that we're working with, which is kind of the first step into a crate type environment. And, that's one of the things with our vehicle intelligence platform or our wireless battery system. where you then have the ability to open it up and you have the ability to put it into applications that you just couldn't imagine before. And that wireless battery management system in that VIP architecture is a great example of you got power, you got cooling, and everything else is wireless. And so it's sort of like the Wi-Fi versus the old landlines on the dial-up, where we can't even imagine where it's going to go. And I'm sure that'll be something that we announce in the future.
A big part of today's presentation was sort of the transformation at Cadillac. You guys have been pretty, forward-looking in making this, this luxury brand. The mission really all about electric vehicles and really taking a position and trying to redefine in some ways what luxury means and making, electrification part of that conversation. The Celestiq, we sort of saw it in the shadows there. It was a really beautiful looking vehicle. And I think, to me, a lot of this is about not just, the technology, but making these aspirational vehicles, things that people want to buy. You've seen Tesla obviously achieve some success with that. Other car companies, some of their electric vehicles tend to, be a little more conventional. And I think you guys have sort of done that, both approaches, actually. The original Chevy Volt was pretty futuristic, and then it became a little more, more conventional and in line with consumer tastes. But just looking at some of these shots of the Cadillacs, I mean, they're very impressive vehicles, gorgeous cars. They really make a design statement, something that I think could get people excited. Tim, I know you're an engineer, not a design guy, but you must be excited seeing things like that hidden away kind of in the depths of GM, wherever you guys are keeping these prototypes. To me, it's something that I think gets the average consumer excited about an electric vehicle.
Yeah, it's really infectious enthusiasm. And you saw some of those designers, right? And so we'll interact with the designers and they'll say, hey, I'd like to try this. Is that possible? And we'll say, sure. The Ultium architecture and the Ultium platform can make that happen. And so that enthusiasm just kind of multiplies and it gets more infectious as it goes forward. I particularly like some of this Ultrafy, where it's all going to be on your phone and it's all transparent. To have a very good user interface with that. And just wrapping that total package together is giving us options that we could only dream of as little as 3 years ago.
That kind of, I almost think begs the question is, what else could Ultium do? What advantages can it give you guys that a traditional car, just a gasoline-fed engine, you wouldn't even have that sort of technology on the car. But with Ultium, you've already got some of this infrastructure built in.
Yeah, the electrified part of it, right? Some of those panel roofs that you had there came from the ability of having this strong electric system. Some of those rock crawling modes on the one pedal mode with that torque control and how you have that instantaneous feedback of applying torque, but you also have the sensing capability to know which wheel is turning and then how it's all integrated together in that vehicle intelligence platform. And so, I am a bit biased. I've only driven electric, for 6 years now. But the one pedal drive that we had on the Chevy Bolt, we thought was kind of going to get diminishing returns after that, and we couldn't imagine it getting much better. Now we do this one pedal drive on this Hummer, especially during this rock crawling, and it just is opening up all kinds of possibilities. This watts to freedom mode, where we have, I always call it the ultimate power has the ultimate responsibility. And you can make all that happen where we can enjoy a 3-second car and we don't have to be track certified. So a lot of this integration and a lot of this capability, it just continues to amaze me as to, where it's going to go tomorrow with so many creative people and so many innovators working on it. I couldn't even begin to comprehend where it might all come together 5 years from now.
How many folks do you guys have at GM working on electric vehicle technology now? I know it's a very big company, hundreds of thousands of workers, but roughly how many people are working on EVs?
It's a large amount, and they're converting more and more every month as the products start to roll out. And so, where do you draw the line? How do you differentiate it? I mean, I call those designers we worked with EV enthusiasts now, and they're working on the EVs, whether it be the Lyriq or the Hummer or some of the other ones that we got coming out with this full line of Buicks coming out. So I would say it's the vast majority of the company right now. And, you may have noticed that we're going to hire a lot more, and we're really going to have this connected customer and the software development where we're bringing in thousands and thousands of more experts. So if you want to work on great technology and you want to, be part of the innovation and be part of the creativity, definitely GM can use you. So come on in.
What are some of the challenges and some of the strategies for getting people into these electric cars? I know GM's been around for forever, and you have these legacy customers. Some of them, might be sort of stuck in their ways. They want a diesel pickup that can tow, 500, 700 miles without without stopping. How do you convince these folks to give up the internal combustion and go to electrification?
I think we let the customers drive us as to where they want to go. And so if you look at what they're looking for, we have the telematics on board, so we know how they're using these vehicles. Through that brand name OnStar, we're also able to say, well, how far do you drive, and when do you need to do a fast charge? And, some of that 90 miles in 10 minutes drove us from our customer feedback, because although they only do it maybe once every 2 years, they want to have a vehicle that has that capability. And so we really have to meet the customers where they are, and then we really have to listen to them and have the technology ready to meet their needs. We have great retention on our existing vehicles. If you look at, Bolt EV drivers and user forums, they all love the vehicle. And so you have to maintain that, right? You have to make sure that the next one coming out is even more exciting and it doesn't disappoint in any ways. But even if it doesn't disappoint, you have to say, well, what would you like to make better? And, part of that whole scenario of continuous innovation where, we love making it better, and we love getting this feedback from our customers to say, tweak it here, make this a little bit better. And it just keeps on evolving with them as that goes through. And so I really think it's one of those things where, we expose them to it. They tell us what they like. Most of them are very enthusiastic, very, very few negative feedback. But when there is something that you want to improve, go fix it. And, kind of this whole, 238 up to 258 miles on the Bolt EV was a range thing. And now we're going up into the 300 and 450 mile EVs. To further reduce that range topic is kind of related to what you're talking about. But we have to say, we're never stopping, and we're going to always improve. And once Mei Kai's cell gets in here, it's almost, how should I say it, another inflection point where it's going to, reduce the weight, improve the rock crawling capability, and getting down to the bottom of that cost curve where we don't know how low it is right now, but we're going to get there as quick as we can.
The GMC
solid state.
Go ahead, John.
Go ahead, Greg.
Oh no, go ahead. I'm curious what you're going to say. That sounds interesting. That sounds like a very.
I'm just curious if solid state batteries are part of the plan at all. Is that in the works for GM?
Yeah, and the terms are pretty loose, right? So we're going to have always the cutting edge pioneering battery chemistry. Whether it's a hybrid electrolyte or a solid state electrolyte, or the different, anode technologies. I mentioned the protected lithium anode to remove the graphite out of the cell and make more room for higher range. So all of those, we have those kind of three major cycles of innovation, where not only do we prove it in the lab, we have a manufacturing team working with our Ohio factory to say, well, how would you get that into scale production? And then all the value chain to say, well, okay, now, if you look at some of these next generation products, it's a great competition because you have the graphites competing against the lithium anodes, and you just keep on working them to make them both the best they can be. And with a wide portfolio, it'll probably coexist. And offering those types of customer choices at scale is part of the exciting part of the next 5 years in the industry.
Tim, could you kind of talk a little bit about the size of what an Ultium battery pack, just compare it to something for the average person? Like, is it like a thing of fruit, like a jug of milk? Like, how big are we talking about here for the Ultium battery packs?
Yeah, so if you kind of look at some of those things there, those are your 300, 350-mile packs, and it's basically the footprint of the vehicle as you look underneath the vehicle there. And so, with that footprint of the vehicle, you have a lot of the advantages where it's a low center of gravity and it's a very stiff chassis because the battery cells and the cell module assemblies actually assist in the structure of the vehicle, so you can have that firmly planted feel while you're driving the vehicle. And then as we get into the next generation technologies, or even this generation, you can make them smaller. And you heard us talk about a 6 or an 8, a 10, a 12, up to a 24 module with a double stack battery. And we have all those options. What you're seeing on the screen now is kind of a 12 stacker. But then you can shrink that up. And so you'll basically pull it back from the rear wheel so there's actually a little more space and a little lighter weight for, say, a 6-module battery pack that goes together. But it's always basically the width of the car. And then we just stack them in. And on the trucks, we double stack them to put them double high.
That really opens up some packaging opportunities for you guys. I remember driving the Chevy Volt, some of the earlier versions of it, and it was like a T-shaped cell sort of thing that ran right down the middle. And for a while, I think it was actually only a 4-seat car, and then you guys were able to add like a middle seat. And to me, that's one of the exciting things about electric vehicles is, you don't have a traditional internal combustion engine right in the front, and it opens up space and opportunities for things to add new features, to add new like seating configurations, things like that. Even with the Volt, with the T-cell, that car was incredibly well planted. It drove in some ways like a sports sedan because it was so low and planted to the ground with those battery cells. What are you guys thinking about as you look at these new like open spaces in the car that you can put things in and add new storage and try new things?
Yeah, the designers are really excited, and some of the fundamentals, and I'm not a designer, I can just play one on TV here. But ball of foot to front axle, you have a lot of flexibility now. The slope of the windshield, you have a lot of flexibility now. If you look at some of the rear packaging options that you have with that very tight suspension back there, it gives you even more capability. So each designer and each brand is taking this freedom, and they're going to go make their specific statements without any of those constraints that they used to have. And so it's a pretty exciting time to see what they come up with. If you look at the Hummer Super Truck, right? I mean, to take the roof off and throw it in the frunk was a great example of some pretty creative use while you still had all that off-road rock crawling capability with that front locking differential. So, if you look at, what these designers will come up with, you're starting to see some of the excitement now and those special individual lighting systems through the glass panel roofs. There's more and more of that coming, so stay tuned. I think you're going to be amazed with the creativity of our designers.
Yeah, I got to say, I saw the Celestiq in person, and it really is an impressive vehicle. The way that it greets you when you walk up to it, the lighting display on the grill, and then on the side, goes down the sides and the door handles, and then you get inside and everything is lit up, and everything's a screen too. There's a screen on the steering wheel. There's a screen all the way across the dash. There's screens on the center consoles, front and rear. Everything's a touch screen, and everything's sort of usable. This space is more of a lounge, a place where someone wants to spend time. It's not specifically an appliance to get you from place to place. It was a very emotional vehicle, and it was really cool to see how excited designers were about the freedom that these EVs give them to just recreate the brand and create a new halo for the brand too.
Yeah, it's kind of neat. It's not just physical options they have, but it's also, like you said, the screen options and the ability to reconfigure and grab and toss and a lot of that stuff that you used to just see in movies, and now you can live it yourself. So I'm sure we're going to see stuff that we, literally didn't think was possible, and is going to happen in this generation of Ultium architecture.
How does Altium sort of reinforce BrightDrop, which was a new service we heard today, and that's pretty exciting. That's something that, especially with the way shipping and the way people now shop, has really been transformed in the last 11 months now. It seems like you guys are really trying to meet the moment with BrightDrop, and then using electric propulsion really as a way to rethink how you do that.
Yeah, and it's all tied together in the fundamental architecture with the vehicle intelligence program. I call it the telematics, where we've got the cloud-based systems up and running. And so BrightDrop was a very quick, natural adaptation on how to really take a pain point for that customer. And, I think you heard they had a 20% improvement in productivity, but fatigue goes down. It's easier to use. Everything is centrally located in that cloud. You're never worried about state of charge on your BrightDrop module. It's all right there. And you can, it's sort of like teaming up now, where you're not just trying to run your route by yourself, but you've got all this extra information and ways to optimize it. And so it really is a better way of doing business and a better way of doing life. So we're excited about those types of new opportunities with just, very minor adaptations to some of the systems that we already have in place.
Can you talk a little bit more about the drone, the Verton? Were you involved with that at all? I'm sure you were, as it's electrically powered, but I'm curious as to how far out that is, and just some of the thinking behind it, and some of the applications for that.
Yeah, I think it's another good example of, you think about how it ties together with that Altium architecture and that vehicle intelligence platform. And to say that, well, now you're going to make a smaller vehicle that has similar power, but you're going to drone from spot to spot. It's all capable within the physics. Now, where's the customer need? Where's the customer demand? And where's the customer confidence in making all that come together? But I think you kind of have seen, the small scale drones have really been very useful in many industries. And this is just a natural evolution where you take some of these common Altium components and you can be very useful in some of these situations. So I don't think they've announced timing on that yet, but that it is all within the Altium architecture that you can make it all happen. And it really comes down to how do you take the autonomous, tie it together with the power of the Hummer, tie it with the quality of the Altium cell moving forward, and offer a very compelling product that could be very useful for some of our customers.
Tim, what would you say the biggest learnings General Motors as a company has, I would say, achieved over the last, really 30 years, even going back to the EV1? You guys were among the first to get into the electric vehicle space, followed up by the Volt, the Bolt, and now we're looking at this whole new range of electric vehicles that really is going to come to dominate your portfolio. What are just some of the big takeaways you've learned about developing the batteries and consumer preference?
Yeah, that's a great question. So if you kind of look back, right, and we have some of these old guy like me museum pieces out there, right? And you take the EV1 battery pack, and it's kind of the same size as a Volt battery pack. And the Volt battery pack was about 18 kilowatt hours. And now you look at a 60 kilowatt hour Bolt EV battery pack compared to those two. And it's not only the chemistry that goes inside of it and how to manufacture that chemistry, but it's how to manage it, to equalize it. It's how to condition it with our active heat pump systems. It's how do the customers use it and how do they charge it? And then how do you have all of that tied together so you have the right technology in without waste. And so, one good example we had just in the Ultium is that we used to do a quick evaluation of new technology chemistry and would run it at 65 degrees Celsius, just because that was a very representative way to get a quick test to say, well, A is better than B on a comparative basis. We knew our customers never did that, but that became one of those good benchmarks when you say, well, how am I going to upgrade? How do I go from a 38-mile extended range up to the 55-mile extended range? But then when we got into this new technology with this MCMA, those methods didn't work anymore. And you actually had to develop new methods with technology. And it's a little generic response to your question, but you can never stand still. You always have to innovate, and then you can't get stuck in well, that's what we did before, and we got to do it this way again. We always got to do it new, better, faster on each generation with the new technology, while we're protecting the customer to make sure that we don't miss any steps and that we give them a very durable product. And so far on the Bolt EV, we've had some great experience with, many people over 100,000 miles and going strong. I think on the Chevy Volt extended range, some of our customers were up at 500,000 miles with that. And so, getting that feedback in to say, well, let's go get those parts back. How did they wear out? How did our acceleration techniques and validation compare to the reality of the field? And then how do we iterate that global development process so we can do it faster and accept better technology sooner while still having that high quality of release? And so innovation, I think, is the biggest way. It's more of a processing question than a one technology, because about every 3 years, we're getting these major improvements in battery chemistry, major improvements in motors and power electronics, and major improvements on the interior. If you look at auto cruise right now, today, that's not so much battery and chemistry and power side, but the ability to say that we're going to have that experience for the customer with all that related technology on these electrified platforms is just very powerful, and it just takes that constant innovation. So I hope that answered your question. I hope it wasn't too vague.
No, that was great. That was great. Something else that I think is on the mind of consumers is the infrastructure. Right now, if you need to fill up your car, you go to the gas station that's on your corner, and it's easy. And you could Google the price of gas. All this stuff has been around for over 100 years. What are you guys looking at as far as sort of meeting the challenge with infrastructure, partnering, developing some of your own features for this? Because that really is something that could speed rollout and make this just so much easier for your average American if there were like charge stations on their corner.
Yeah, I'll say it's going to be a new world out there, and I've got kids and college kids and stuff like that, and they actually get annoyed going to the corner if they have to go fuel up on the Chevy Volt extended range, and so a lot of the customer experience with that Ultify, we can get the charge station installed in your house or your apartment where it's very convenient for you. You'll never go to the corner, because you don't need to unless you want to go there for something else. And that's many of our customers' experiences. Like 80% of our customers never go to a fast charger at any time, and they charge at home. Another approximately 18% of our customers, they charge at work, because they have that ability to do that. And so that's a very natural infrastructure, and we want to keep that going. When it comes to fast charge, we partner with multiple people, and I like to call it universal charging, okay, where it's not a special station. It's an interoperable standard, and you plug in and you fast charge. And then most importantly is on your phone, you have this great little application that knows where you're going and your route and your plans, and it ties it all together to say, well, listen, you probably don't need to fast charge today, and you can just run the whole day. Or if you got a longer route with that, here's a convenient time for you to fast charge, just not when you get empty, and then you can finish your day. So you kind of combine route management, like you kind of do on the fleet that we're talking about, with personal use. And quite frankly, my 1-year-old, he doesn't ever purchase fuel. He doesn't ever go to the gas station because he's got those types of systems that he relies on all the time, and it's much, much less expensive to make it all happen. And so, and I think a part of it is that somebody else always pays for his electricity, so that's an extra bonus to him, and he's never got a transportation expense. So I think all that'll come together, and many of our users will have those choices to do that universal charging, whether it be at home, at work, on the road, anywhere in between.
Tim, thank you so much for your insight today. John, thanks for being with us as well. We're out of time. It's been a great segment. I've enjoyed this immensely. Stay with us for all the coverage from CES. At 10:30, Chip Wars is coming up. And of course, Wednesday at 4:30, the official Best of CES Awards, 4:30 Eastern. Come back for those as well. Thanks again. Enjoy the day.
...2020 has been another big year for PC performance enthusiasts, with more cores and more speed for less cash. It is a great time to buy a new processor, but there are some big shakeups looming on the horizon. Welcome to Upskilled, our explainer show, where we mostly just seem to break down why AMD is good now. This is a special year-end episode, and I wanted to look back over the year in CPUs. The biggest news of 2020 for PCs was probably Zen 3. AMD launched the next generation of its desktop processors this fall, and actually managed to follow through on a promised 20% improvement in performance without increasing power requirements or moving to an improved manufacturing process. Compared to just a few years ago, AMD is still delivering pretty incredible performance per dollar and has helped push 6 and 8 core chips into the mainstream. We took a closer look at their flagship 16-core chip, the 5950X, and were blown away by how fast it was for media and content creation work, though it is definitely overkill for most people. On the mobile front, 2020 also saw the release of AMD's Ryzen 4000 series laptop chips. As popular as Zen has been for desktop CPUs, that market is a fraction of the size of the laptop world, and up until these Ryzen 4000 chips, AMD didn't really have a good challenge to Intel's speedy laptop CPUs. We like to focus on the top-end desktop chips, but come on, most folks actually buy laptops. With chips like the 4800 and 4900HS, AMD was able to bring enough power for some serious workloads like video editing to a mid-size laptop. Seriously, the 4900HS scores about as well as Intel's desktop i9-9700K in some benchmarks, and beats AMD's 2018 flagship, the 2700X, by a wide margin. Side note, if you are looking for a laptop, our editor Devindra tested out and was pretty impressed by the Ryzen 4000 powered ASUS ROG Zephyrus G14. While the Ryzen 4000 and 5000 series chips are hugely impressive, I do feel like I'm starting to see some online grumbling. With Intel continuing to price its processors maybe a bit higher than I would, and not really offering a compelling performance advantage, AMD's prices have started to rise. Last year's 3800X launched at $400, but this year's equivalent 5800X is $450. And heck, going back 2 years to that 2700X, that was only $330. Is the 5800X better and faster? Absolutely, but either way, we are seeing AMD's prices drift higher. Now, we may see cheaper releases in 2021, and these new chips really are much faster, but for a lot of fans who flocked to AMD as a cheaper but still really fast alternative to Intel, it is a little hard to stomach. What we really need is some more competition. So it would have been great if 2020 was the year that Intel came roaring back with a slate of killer high-performance processors, ones so good that AMD would have to slash prices in order to keep up with them. But 2020 was not the year for that. This past spring saw the release of Intel's 10th gen Comet Lake desktop processors with the flagship 10-core i9-10900K. We tested out some of these chips and they're fine. Honestly, they're really fine, but all of them are maybe a little bit too expensive for the performance you get. Comet Lake is the maybe fifth iteration of Intel's 14nm process? I'm not sure. I have completely lost track because they stopped adding pluses after 14+++, so who can say? When we tested the 10900K, it was plenty fast, but it ran super hot and sucked down more than 200 watts of power. Intel's in a bit of a rough spot here. Their long-awaited 10nm manufacturing process, which promises better performance and less power usage, still seems to be barely off the ground. So they're stuck just adding more cores to the same tweaked design we've seen for half a decade now. The reality is, at most of the higher end, there is an AMD chip that probably runs a little bit faster, uses less power, and again, this still kind of blows my mind, probably costs less than a lot of Intel's competing products. Things did get a lot more interesting at the low end, though. With these 10th gen processors, Intel is finally offering hyper-threading, essentially processor multitasking, all the way down to its cheapest CPUs. You can get an i3-10300 chip that's about the equivalent of their flagship i7-6700K from a few years ago for just $175. And as we found in our testing, paired with a decent GPU, that is still plenty fast for most gaming. Still, while the cheapest new AMD chip is $300, if you're willing to just step back a generation, the Ryzen 3 3100 is a $185 processor that offers slightly better multi-core performance at the expense of slightly worse single-core, compared to the i3-10300 for just a few bucks more. One thing holding Intel back is they still haven't given us native desktop support for PCI Express 4.0. This is the high-speed interface used by add-in cards like GPUs, and more importantly, for super fast NVMe-based solid-state drives. While modern graphics cards aren't really fast enough to take advantage of PCIe 4.0 yet, there are plenty of solid-state drives showing up that have read and write speeds over 5 gigabytes a second. Remember when the 400 megabytes or so of the first flash drives felt super speedy? PCI Express 4.0 is expected on Intel's next chips called Rocket Lake. Confusingly, Intel's 10th generation chips on mobile are entirely different. While they actually premiered in 2019, this year finally saw the wide release of chips based on their Ice Lake design, like the i7-1065G7, which is made with that long-awaited 10nm process. And they're fine. Again, they're kind of just fine. They're pretty efficient, and the integrated Iris Pro GPU is a big leap forward for Intel's graphics capabilities, but they're kind of held back by slow clock speeds, and so far the 10nm chips just haven't really made a splash. We also saw the release of the first chips for Intel's follow-up to Ice Lake, Tiger Lake, which is built on an improved 10nm process and features a redesigned core architecture. Tiger Lake, or 11th gen chips, are starting to show up in new laptops like the Dell Inspiron and XPS 13, but so far we've only been able to test the higher-end i7-1185G7 in a prototype machine. And again, who is coming up with these names? Tiger Lake bumps up cache sizes and does bring some improvements in clock speeds, but the biggest changes are in Intel's integrated GPU. Tiger Lake features Intel's brand new redesigned Xe graphics architecture, and we found it was good enough to get around 50 or 60 frames per second at 1080 resolution in medium settings in Overwatch, which is not bad for an integrated GPU. These chips should offer some boosts in performance for the ultra-portable segment, but for serious workloads like rendering and video editing, with only 4 cores, these Tiger Lake chips seem to be struggling to keep up with AMD's 4000 series chips, which have been out for a year and were actually based on even older Zen 2 technology. Intel did also launch its new Lakefield chips based on its Foveros design. which takes the various chip components and stacks them vertically. Designed for low-power devices like tablets and ultra-portables, the first Lakefield devices we've seen are actually pretty impressive, delivering decent performance while only sipping a few watts of power. In our editor Sherlin's recent testing, the Lakefield-powered ThinkPad Fold X1 actually bested an iPad Pro in a video playback battery life test. The Lakefield design, with its vertically stacked chips and a smartphone-esque mix of high and low-power cores, is actually a pretty big deal. Intel has essentially taken a chiplet manufactured at 10 nanometers and containing 5 processor cores, the graphics and other logic, and glued it on top of a 22 nanometer chiplet containing things like the USB and storage controllers. This is akin to AMD's use of a 7 nanometer processor chiplet and a 14 nanometer input-output chiplet, but it's new from Intel, and the vertical stacking design is unique. Lakefield has some big potential advantages in areas like power consumption and memory access, and though the current chips max out at a mere 7 watts of power, it may give us a clue for what Intel has planned in the future. So what do we have to look forward to in 2021? Well, it may actually be a pretty quiet year for AMD. The current crazy unsourced rumors are that they're pretty happy with their position in the market at the moment, and they are going to take their time with Zen 4, so we may not see a major release from them until 2022. 2021 will likely bring a refresh of Zen 3, sort of like they did with the older 3800 XT chips, essentially the same processor at higher clock speeds, and we may see some more processor options, including lower-end ones like a 5300 or equivalent. We may also see an update to AMD's laptop chips. Remember, those Ryzen 4000 series are actually based on what is now pretty old technology, but that may be about it. When Zen 4 does arrive, it may be a bigger change. We know for sure it'll be moving to an improved 5 nanometer manufacturing process, and said crazy rumors suggest that AMD is trying to support super fast DDR5 memory, along with a rework of that input-output die, which hasn't really changed in a few years, and an overhaul of the Infinity Fabric, which is the connection that links all the different parts of the processor together. This increase in speeds, along with a massive Navi-esque L4 cache, a design borrowed from their new graphics cards, could lead to a big improvement in that all-important instructions per clock metric, which is building on some of the advances we actually saw in this year's Zen 3. But again, crazy rumors. Zen 4 will also move to a new motherboard socket. Now, AMD has actually done a pretty good job supporting older motherboards, though some folks may never get support for this year's Zen 3 chips. But they've been using the AM4 socket since 2016. By contrast, Intel seems to require a new motherboard every single year. AM4 has had some inherent limitations, including a fragile pin design that some folks dislike, and a power cap of 142 watts. Moving away from that could change a lot of things, namely higher powered processors and maybe improved I/O options for connecting up all that super fast PCIe 4.0 storage. We're also getting more info about Rocket Lake, Intel's next desktop chips, which take the improved core design from Tiger Lake on mobile and backports it to some sort of 14 nanometer quintuple plus process. Rocket Lake should finally add support for PCI Express 4.0, but it seems like it'll max out at 8 cores, which means that unless those cores come with a serious improvement in performance or speed, it's going to face some stiff competition. At this point, it seems like we won't see a high-performance 10 nanometer desktop chip from Intel until 2022, when their Alder Lake platform is set to launch, which should feature an entirely redesigned architecture, along with maybe a mobile-esque mix of high and low-powered cores. Of course, the shadow looming over all of this is Apple. Their new homegrown M1 chips are seriously fast, and what we've seen so far is essentially just an iPad Pro chip in a fancier package. Our review by our editor Devindra found that the M1 powered MacBook Air actually bested that Zephyrus G14 in single core performance in Geekbench, though there's a reason to not entirely trust benchmarks comparing the M1 chips to other processors. Stay tuned for our episode on the M1, it's coming up next, and we're gonna dig into it. To achieve these speeds, along with great battery life, the M1 pairs 4 high-powered and 4 low-powered cores. Are you seeing a trend here? But Bloomberg, who got the scoop on the M1 in the first place, says Apple is planning to release computers with 12 or even 16 high-performance cores as soon as spring 2021. Bloomberg, in fact, reports that Apple is even trialing a 32-core version of the M1 for a refreshed Mac Pro that may be released in the fall. Pair these chips with a 32, 64, or even 128-core GPU, up from just 8 in the current M1s, and you've got what has the potential to be the fastest chip you can get, hands down. There also may be contenders from the world of RISC-V. As we mentioned in our video on that topic, this open source chip design is finally entering the mainstream. Chip designer Sci5 just announced the Hi5 Unmatched, a 5-core Linux-compatible system based on RISC-V. While these early chips are unlikely to be performance champs, Micromagic just announced they managed to get a RISC-V design to run at 5 gigahertz of speed on just a single watt of power. This is still early days, but that's potentially as much as 13 times as efficient as even the M1. And another of their designs might be as much as 10,000 times as efficient per watt. So RISC-V definitely has some potential. 2020 was another great year for processors. It really feels like 8 cores has become the high-performance standard, maybe helped along a bit by the new consoles, but we've never had so many great options to choose from, all the way down to solid choices for 4-core chips under $200, up to 16-core processors and beyond. And while I wouldn't expect any huge new releases from Intel or AMD in 2021, we really are entering a new era of computing, with Apple and a host of startups looking like they are poised to release some truly revolutionary chips. And we'll be here testing them all out and trying to figure out how the heck they all work. So thank you again for watching, be sure to like and subscribe, and we'll see you in the new year.
Hey everybody, welcome back to Engadget's live coverage of CES 2021. I'm senior editor Devendra Hardawar. I'm joined by our video producer Chris Schott. Hey Chris, how's it going?
Not bad. Thanks for having me here, Dev.
Yeah. I mean, this is all you, Chris. Like, we just saw your upscaled segment about the state of chips today, and we are now gearing up for AMD's CES press conference, which starts at 11 a.m. Eastern. I'm really excited about that. Where do you think Intel and AMD sit now, since you did that upscaled episode? Because we got a couple Intel tidbits yesterday, right? We heard about the new H series chips. We got some previews of Alder Lake. How do you feel about Intel and AMD at this point?
So the position hasn't changed a lot, but I do think a couple of the criticisms I had with Intel in that piece, especially that we just weren't seeing many of their 11th gen chips in the market yet, despite announcements. It looks like they're working hard to rectify that. And some of those actually do bring pretty impressive performance gains. This is one of the biggest architecture changes I feel like we've, as I've complained about maybe endlessly in my pieces, we've seen a lot of iterations of the Skylake architecture, which was really successful, but came out quite a while ago. And there's been a big string of, I mean, at this point, it's hard to, you'd be hard pressed to look at the most recent chips in that line and say they were directly related to Skylake that came before it. But it's been a series of incremental changes year by year. And these are much bigger redesigns from the ground up, really targeting a lot of kind of the bottlenecks in modern computing with cache performance and things like that. And they actually seem pretty impressive. I don't know if it's enough to dethrone AMD as the current, performance champs, but Intel, they've really, especially those low-powered chips, I'm pretty impressed by what they're at least saying they can do.
How do you feel about the new Intel H series chips? So yesterday they announced that the first batch are actually aimed at basically ultra portable gaming notebooks, right? So, and they top out at 4 cores, which doesn't feel like an H series chip to me, but they say the single threaded performance is better than last year's highest end H series notebook chip. So I guess they're really focusing on single threaded. How do you feel about that and that category of ultra portable gaming laptops under 4 pounds?
So it's not a product I would buy, but but I can actually see there might be people who would. I guess for me, most of my machines, I want to make sure I can do some productivity work on, and there the 4 cores feels like maybe it's not quite enough. But if you really do want a machine to play some Fortnite and maybe Apex Legends and maybe even Warzone, a game that's a little more graphics intensive, you really don't need a particularly intense processor, and single thread performance does tend to be kind of the limiting factor. So it's an odd thing, in my opinion, to target, but there very well might be a market for it, and they could deliver some of what they're claiming is their goal with these processors. It just feels like it's very niche to me when I still want my machines to be a little more general purpose, I guess.
It's very specific, right? And it's also like Intel's talking about ultra portable gaming notebooks. Like, this is a brand new thing, except last year AMD kind of made those reality with the Ryzen 4000 chips, right? You talked about the Zephyrus G14, my favorite gaming laptop of last year. That thing weighed 3.5 pounds, and it had an 8-core Ryzen chip. It had RTX 2060 graphics. That thing was just like a powerhouse, and that was just so portable. I'm kind of wondering if Intel is still lagging behind that. Yeah.
I do feel like they are a little better. You edited, or you reviewed that computer. I edited the review, so I got to see pretty closely your testing on it and everything. And I feel like that was the computer that kept coming up over and over again throughout the year, essentially, of like, you're checking out a new laptop, this Asus Zephyrus ROG G14. That is a heck of a name. But it's surprisingly good performance. I even recommended it to a friend's mom, which is that's not really a target market, but they wanted a computer that could do some higher performance things. Like, they wanted to do some pretty intense Photoshop and image manipulation stuff. And I was like, well, for the price, and you're not going to be carrying it around out of the house a lot, maybe get this gaming laptop.
Right.
But,
the only downside was that there was no webcam, right? So that felt like the big caveat for a lot of people last year. Maybe this year things will change because we're expecting whole new machines from ASUS and everybody. What are you expecting for AMD, right? Because I think the expectation is Ryzen 5000 mobile chips, right? And what does AMD really need to do to improve on last year? Because 4000 seemed really good. It just seemed like it took a while for us to actually see it in machines.
Yeah, so that was the big issue. As I mentioned in that video, the 4000 series is based on chip tech that at this point is a little old. It was kind of a generation behind, and now the desktop generation has even moved forward again. We had this Zen 3 just launch in the fall, and kind of the big key selling point of the Zen 3 processors was this incredible performance or instruction per clock rate, essentially, like how much work it's doing on each cycle. And if they can just bring that improvement down to the mobile chips, there'll be a really big leap forward over last year's processors. They don't actually have to really reinvent the wheel. They just have to take what they've already done on the desktop and repeat the success of the 4000 series, where, it's pretty reasonable to expect the 5000 will bring about a 20% boost in performance without taking more power or needing a ton more cores. So AMD's pretty set up to deliver some potentially pretty impressive laptop chips themselves. I would kind of be shocked if they don't, actually.
Yeah, it's probably last year and this year, great times to buy a laptop. Just talking about Intel here, we were talking about the H series chips, right? So what they're doing is they're producing these kind of lower powered H series chips first, and then the high end, the 8-core chips are going to be coming at the end of this first quarter. So I guess that's what's going to be in like the follow up to a lot of the gaming machines from last year. Intel also talked about their upcoming Rocket Lake S chip, right? That's going to be the 11900K. There was some surprising stuff there, right? Because they're actually going back to 8 cores, whereas last year's, super popular, just spec popping chip, the 10900K, was 10 cores, got up to like 5.3 gigahertz. Like, is this a step back for Intel, you think, or is the focus on better single-threaded performance kind of better, for more people?
So it's tricky. It's a little bit of both. I have to imagine in an ideal world, Intel wouldn't be building these back on a 14 nanometer process. Their laptop chips have almost all moved to 10 nanometer. As we know, the smaller your transistors, generally, huge generalizations, but the less power it takes to run them. And I just have to imagine if they could have chosen, they wouldn't pick to be building these on a 14 nanometer process. But that said, they've been using that manufacturing for a long time. They are very good at it, and they're very good at getting high clock speeds out of it. I do think stepping back to 8 cores is a little odd, but at least the early leaks and rumors and stuff we've seen suggest that that not only do these chips run fast enough that the 8-core chip is probably faster than last year's 10-core, but that also, even with 8 cores, it probably still draws upwards of 250 watts of power, and they might not be able to put 2 more cores on there. They may be running into a heat and power limit. This is still, these Rocket Lakes are adopting this improved new mobile design I've been talking about. It's the kind of on desktop, the first big break from that chain of Skylake-derived chips. They are going to be working slightly differently. I mean, I don't disbelieve at least the rumors and suggestions that their single-core performance really is taking a big jump forward, and that is going to make them faster than their 10-core competitors from last year. The big question is, are they faster than AMD's 12 and 16-core chips? And I'm not, we got to test. Not sure yet.
That's going to be hard to tell, too. And how do you feel like, I don't know if you've gotten a chance to do your testing of the ARM chips at this point, or the M1. I feel like Apple just took a lot of wind out of the sails of both Intel and AMD with that chip, because I was testing the MacBook Air, and this thing was just clocking insane numbers. How do you feel that kind of changed the landscape?
So last week I spent 3 afternoons on the phone with experts where I essentially just asked the same question of how the heck did Apple build this over and over again? You did our official review of these products. I'm trying to dig into the architecture side, but what was your impression as you were actually testing these?
I mean, they just feel astoundingly fast. I can't remember the last time I felt like just such a huge generational leap in chip performance, right? With the MacBook Air, the instant you open it up, it's on, you ask it to do anything, it is like there. I ran Geekbench, I ran a couple of things. It just blew through what we expected from desktop chips. And I think that just kind of shattered my worldview a little, right? Because we normally think of mobile chips and ARM chips as these sort of like, oh, that's cute. You're doing a decent amount of performance. Oh, you're trying to pretend to be a desktop or something. But I think Apple kind of fundamentally showed that no, actually, mobile chips and the efficiency and power you could get from a mobile chip can actually now compete with desktops and actually, basically do even better. I'm thinking of like when Apple announced the M1, right? They showed off some charts that showed the progression of the speeds of every generation of their machines or of their chips. And basically, you could see the intersection point where the A14 started to be faster than the stuff we were seeing from Intel. And I think that's when you realize last year, Apple really had to make a choice, right? Are they going to sit back and wait for Intel to kind of up its game a little? Or are they going to just like rely on their own tech that they've been building for mobile devices for so long and basically chart their own path into the future? And it seems like that was Apple's decision. I feel like that just shows a huge failure on Intel's part, right? Like, not only are they delaying 7 nanometer, they can't even keep their key partner on board because they're so slow with their designs.
Yeah, I mean, my big takeaway was my personal laptop is a 16-inch MacBook Pro with an 8-core i9, and that was my main computer that I benchmarked against the 13-inch MacBook Pro with the M1. In Geekbench, it is hugely faster in single core, though as I'm trying to dig into my episode, that's not actually the best metric. But in multi-core, it was still a point or two faster. This is it's an 8-core chip, but it's 4 high-powered and 4 low-powered cores. And actually, the real, get rid of Geekbench, get rid of the synthetics. I also just installed Premiere Pro on the darn thing and exported a 5 gig chunk of 4K footage actually from one of our Xbox reviews that I've been using as kind of a standard test clip. My 8-core Intel i9 could reprocess that clip in just about 2 minutes, which is pretty darn fast. And even running through Intel emulation, the M1 did it in about a minute flat.
It's ridiculous. Yeah.
So twice as fast on a chip that doesn't have a fan. It's so low power. I don't get how
It's like magic. It is sort of like even Apple emulating Intel is still faster than Intel. Just imagine like when that app is native, it's ridiculous. Yeah.
Bizarre. Yeah, and I haven't run that test on my 16-core AMD desktop yet, but I'm going to. But I'm fairly certain the last time I actually ran that clip, it took about 1:20, which is just unbelievable. Really, I was calling all these experts, and every question I was just like, how? How did they do this? So we're trying to figure it out, but
that's impressive. Yeah. One thing I want to ask as we're kind of winding down, we're only a couple of minutes away from the AMD keynote. Intel did preview what is coming next for them. So that's going to be 12th gen, I guess, Alder Lake. What do you think about this design? Because now they're getting more into the 3D stacking and the things that they were really building up before, and also having high-powered and low-power cores all together. That is essentially what is working so well in the M1. How do you think about Intel and how they're handling that?
So the 3D stacking thing I actually think is a little more interesting in this case if we are talking the higher performance market. The big and low powered cores, Apple has shown the advantage there in laptops, which to be honest, we've seen the advantage in phones and tablets forever. It's a little surprising people haven't tried this in laptops earlier. The idea is the low powered cores handle your mail client and background tasks, and the high powered cores do your active stuff that the programs you have foregrounded. On desktop, it's a little harder for me to see on desktop the real value of that. It may lead to some power savings, but the average, for better or worse, the average consumer is not terribly concerned about like the average wattage of their desktop system.
Yeah.
But the change to stacking, there could be some really big improvements in memory access by bringing more cache or even RAM kind of directly in contact with the processor dies. Potentially have some lower power usage, improved latency, and I think that's where we could see some big advantages. I'm really curious to see how that actually gets implemented.
Gotcha. Well, I'm excited. I'm excited to see what you cover next on Upscaled, Chris. We're going to be leading into the AMD keynote right now, led by Lisa Su. So we're going to have a lot of information out of that. Chris Schott, thank you so much for chatting about this with me. And stay tuned to Engadget for more live CES 2021 coverage. AMD's coming up next.
Technology changes the world, but not on its own. Hardware needs heart. Software needs soul. When processing power meets brain power, tomorrow comes alive. 1,000 ideas spark inside one mind. The world shrinks. Horizons expand. The speed of progress leaves us breathless. With high-performance computing to lift us, we see more possibilities, new opportunities. We see where the future starts.
Welcome, everyone. Thank you to Gary and to all of you for joining us today at CES 2021. It's an honor to keynote CES for the second time. I know for most of us, we start every January together, so doing a virtual keynote is certainly different. At CES last year, none of us could have imagined all the things that would happen in 2020 as we navigated the COVID-19 pandemic globally. I know it was a challenging year for everyone, but it was also a year where we experienced firsthand the increasingly important role technology plays in every aspect of our lives. For all of us in the tech industry, although we've had our set of challenges, 2020 was perhaps one of our most productive years. From how we work, to how our kids learned, to our entertainment, to accelerating the pace of our digital transformation, high-performance computing has never been more important in our daily lives or to our future. The world needed us to turbocharge our technology capabilities, and our industry delivered wonderfully in so many different ways. At AMD, our focus has always been to push the envelope on high-performance computing across the cloud, infrastructure, and personal computing. And in 2020, we broadened our focus to ensure we were working with our partners to drive innovation, provide more capability, and meet the new requirements of a digital-first world. I'm most proud of the work we have done with technology applied to solve some of the world's most challenging research problems. A great example of this is the work in the scientific community. Scientists and researchers really pivoted on a dime to pool their resources to rally around research on vaccines, therapeutics, and other important learnings to combat and understand the pandemic. And to help them do this, the AMD COVID-19 HPC Fund donated over 12 petaflops of supercomputing last year to many of the world's leading universities and labs conducting infectious disease research. Let's hear from some of the researchers on their work.
When the pandemic came along, there was a remarkable moment. Almost overnight, it seemed, the researchers that had been working on various other applications changed their research quickly to address COVID more directly.
I've never seen such a universal desire to reach out across disciplines to form these interdisciplinary collaborations to try to do what we can to understand this virus, to understand the COVID-19 disease, and to help overcome the pandemic.
I'm the director of the Quran Institute of Mathematical Sciences.
I'm an associate professor of molecular biosciences.
We run the big computers. We do high-performance computing.
I am a professor in the Department of Mathematics and Statistics.
There's never enough computing available. There's always a huge demand.
That is where the AMD donation really comes into play. It's going to allow us to take all of this big data and make sense of it.
The hardware will enable scientific breakthroughs because it has been designed specifically to be an AI-capable machine.
The fact that this new platform that's being provided to us by AMD can do this quadrillion calculations per second will really allow us to build more sophisticated models.
High-performance computing that can process massive amounts of data and then couple it to simulations
to make predictions, it could be just a game changer.
We're going to have the capability of feeding all of these parameters, the molecular parameters, cellular parameters, clinical parameters from patients into machine learning algorithms.
We're now not limited anymore by how quickly those machine learning algorithms can run because of how powerful these new GPU clusters are. Jobs that used to take weeks on a supercomputer to run can happen in a matter of hours.
When you're dealing with a pandemic, time is important, and getting solutions and ideas and possible, therapeutics and drugs as soon as you can is of paramount importance.
We have many people across 55 departments, or more than 55 departments, in fact, that are doing COVID-related research.
The researchers made these rapid changes in their work, and I think that speaks to the generality of the machine learning methods, but also to the power of the computing. And then AMD came along with this remarkable gift of tremendous additional computing power at just the right time to help us accelerate the research results that leads to real answers.
The industry ability to partner with universities is a real boon to scientific development.
It's a really exciting time to be doing science where the computer is really a part of the experiment, can take us to places we never expected we'd be able to go.
People feel like they're a partner, they're part of something important. They all, drop what they have to do and they go work on this thing. We're all in it together, and that is just something really, really nice to see.
Those researchers truly are inspiring. And you know that what they're learning will not only help in this pandemic, but will actually position us much, much better for the future. Now, when the pandemic hit, our lives actually changed, practically overnight, as we went to working, schooling, and sheltering at home. In many businesses, digital transformations that typically would have taken years to complete were adopted in a matter of weeks or months. And while these shifts were challenging on a personal level, the differences were dramatic on the planet. Just take a look at some of the satellite data. This shows the level of harmful emissions in the skies over Europe. Fewer people on the roads meant significantly reduced emissions, improved air quality, and visibly less smog. At the same time, we transitioned to the new normal of working and schooling from home. We've all needed to adapt to new ways of communicating and collaborating, which has placed significantly higher demands on our digital infrastructure and made devices like the PC even more essential. So if you take a look at some of the user stats, Zoom users are now approaching 3.5 trillion minutes of meetings per year. Cisco WebEx meeting participants recently hit 600 million per month. And Microsoft Teams is now supporting 115 million daily active users. All of these examples make it clear how over the last year, our relationship with technology has fundamentally changed. The pandemic has elevated technology to become an essential part of how we live, work, play, and communicate. And at the center of all this technology is high-performance computing. That's why I'm very excited today to be joined by leaders from several of the industry's most important companies to share their perspective on the technology trends and products that will define 2021. Together, we'll show you how advances in high-performance computing will once again reset expectations for what's possible across PCs, gaming, and the data center. So with that as an introduction, let's get started with one of our biggest partners and a company that plays a significant role across each of these markets. To talk more about our work together, please welcome Microsoft Chief Product Officer, Panos Panay.
Hi, Lisa.
Hey, Panos, it's so good to see you. Thank you for joining me today.
You bet.
Boy, I think I've connected with you quite a bit over the past few months on Microsoft Teams, so I feel like I see you in the screen all the time.
We've definitely learned to work together this way, for sure.
So look, it's been an incredible time in the world and, certainly for tech. Microsoft is at the center of that and really empowering people. Can you tell me a little bit about what it's been like for you and the team at Microsoft these last 10 months?
Like many people at Microsoft, they're learning to work differently. And, I feel that certainly. Yesterday I was in a meeting with Satya. My dogs were barking in the background. The garage door opened. And, you're kind of working through it. I think like everybody, we're still adapting, still learning. It takes time. How we connect with each other is changing right now, Lisa, in a huge way. How we work is changing. How we learn is changing. So school, work, even how we're gaming, which is so important to what we do together, and then ultimately we're seeing that, at Microsoft, that PC, it's becoming more essential than it's ever been before, but not only as a productivity tool, but as a tool to connect with other humans and people in general, whether it's at school or work. And you see that. You just said it. As we work together, it's super powerful because we can continue to move forward, continue to push the boundaries. And I think between our companies, it's our responsibility to help tech disappear into the background and help people do that connection. Our customers need that right now more than ever. And so we can talk about how folks are kind of working at Microsoft, but then you can see this intensity of usage of our products together. That's really coming to life. How we support that day in and day out matters, but how we look to the future also. And to your point, whether it's the intensity on Teams or Windows or Azure on the back end supporting so much, or just the delight of being able to game on a PC or an Xbox right now, that you have a whole team at Microsoft, a whole company, if you will, kind of rallying around how to help people stay connected, work, play, and learn, and ultimately being able to partner with AMD has been phenomenal for us.
Well, look, I think, Panos, actually, I think we see it exactly the same way. It's such a special time where we can really use technology to help people do all the things that they need to do, and frankly, it is how we stay connected. So, I'm so proud of the work that we've done together. It's, our partnership is just incredibly broad and, spans all the way from, cloud and data center to, console gaming, and then, to Windows and Surface. It's just been, so great to partner with your team. So can you talk a little bit about some of the co-engineering and what we're trying to accomplish?
Yeah, I think it'd be great. I'd love to. First, let me just say, AMD's momentum right now is incredible. The impact you're having on the world, the work you've done. Let me just say that, and truly from the most humblest place. We've been working together, Lisa, for a long time, you and I. But before I get into any of that, we should start right now. When you talk partnerships, we got to start with gaming, don't we? Working on the Xbox Series X and Series S. This work doesn't happen in a silo. This is two teams getting together, getting right down to the depth of what it means to deliver an incredible gaming experience. Now we have this the most performant console on the planet, and that's the work we do together. I think some people just think sometimes I hear it just happens. No, these are two teams coming together, working in detail. Then take it to the next level, the work you're doing with Azure, the detailed work with AMD and Azure coming together with Epic, delivering for Game Pass and xCloud. These are real depth partnerships. And here's my favorite thing, and the way we work together, and for those of you who don't know, you can take that architecture and that thinking that drives the Xbox, the RDNA architecture, if you will, RDNA 2, I think, and you just move that into what is the PC. And that's what just, now I get super excited, of course, because you know how much I love Windows, how much I love working on these products. Leading into your Radeon product, which has been so incredibly powerful for the PC right now to help gamers push forward, to help the high-performance PC compute happen. And right now, think about customers in this time. We have that intensity of usage. This is even CAD at home or gaming at home, being able to push 64-core computing with Threadripper. You're doing all that with us, but it's really the detailed work of the two teams coming together to bring that to life. But let me also share with you, we created a small video for you, Lisa. I knew what we were coming on today, and I thought, boy, it'd be so fun.
Yeah, I'd love to see it. Panos, that was fantastic. Thank you again for joining us. It was great to see you, and thanks for providing those insights for our audience.
What a blast. Lisa, thank you for having me. I really am grateful, and thank you for this partnership. I think AMD is doing amazing things right now, and your tech is moving this world forward, and we're so grateful for it.
Now let's turn our attention to PCs. In 2020, approximately 300 million notebooks, desktops, and Chromebooks were sold. That's the highest number since 2014. And we expect demand to be even higher in 2021 as the PC continues playing an even larger role in our daily lives. At AMD, we believe the PC has never been more essential. Now, last November, we introduced our first processors powered by our new Zen 3 CPU core. Zen 3 is a new architecture that brings new capabilities to PCs while delivering leadership performance and energy efficiency. The Zen 3 core is a phenomenal example of AMD's dedication to building the best technology. We redesigned the core to deliver our largest generation-over-generation performance increase since we launched the Zen family. Zen 3 increases our lead in overall performance and energy efficiency and also delivers the best single-threaded performance. As a result, the Ryzen 5000 series CPUs are the fastest processors in the world for gamers and creators. Now, we designed Zen 3 to scale from ultra-thin notebooks all the way up to supercomputers. And I'm excited to announce we're starting 2021 by launching the most powerful PC processors ever built for ultra-thin and gaming notebooks. Today, I'm proud to introduce the AMD Ryzen 5000 series mobile processors powered by our new Zen 3 core. These new chips offer both tremendous performance and long battery life. In fact, AMD is the only company with an 8-core x86 processor for ultra-thins. For many years, the notebook PC market was on an incremental pace. By combining our leadership design capabilities with 7-nanometer process technology, our 4000 series mobile processors launched last year set a new performance trajectory for notebook processors. And we continue that new performance trajectory in 2021 with our Ryzen 5000 series mobile processors. You can expect to do more, to be more productive, and to have more immersive gaming experiences with a notebook powered by our new Ryzen mobile processors. Now, with so many of us working and learning from home in 2020, the performance and capabilities of our home PC actually defined how we worked and how we learned and much of our social interaction. We saw our productivity, our ability to create, and our opportunities to connect limited by the computing power of our PC. And for many of us, we wanted more. Our new AMD Ryzen 5000 series mobile processors for ultra-thin notebooks will be a significant step forward in performance and efficiency. With up to 8 of our new Zen 3 cores, the AMD Ryzen 5000 series are the best processors in the world for thin and light notebooks. Whether you're running general office productivity applications or more CPU-intensive tasks like video rendering, photo editing, or 3D design, the Ryzen 5000 series actually sets the new bar for leadership performance. Now, the AMD Ryzen 7 5800U is our best ultra-thin notebook processor. It has 8 cores, 16 threads with a boost up to 4.4 gigahertz, and all of this while operating within a 15-watt thermal design that's required for these ultra-thin notebooks. Now, when you take a look at the benchmarks across a large range of applications, it's just very clear that the Ryzen 7 5800U just runs your software faster. It's a very special product, the fastest x86 processor in the world for thin and light notebooks. Now, the performance is really great, but in the notebook form factor, battery life is also extremely important. And this is where the energy efficiency of the Zen 3 core truly shines. We've just done a ton of optimization in this space, and with the Ryzen 5000 series, you can expect up to 17.5 hours of general use and 21 hours of video playback on a single charge. Now that's a major jump compared to our previous generation and true all-day battery life. Now, notebook customers don't just buy thin and light laptops, but millions of people actually buy notebooks to play PC games. AMD has a rich history in PC gaming and deep ties to the gaming community. Gamers actually want desktop-like performance in the notebook form factor, and that's exactly what we built. Our new HX series mobile processors raise the bar for gaming notebooks. The HX brand actually represents our commitment to build the best processors for gaming. They feature the same Zen 3 cores from our best-in-class Ryzen 5000 desktop processors that deliver leadership frame rates. They're also unlocked for overclocking and have higher thermal ratings for sustained performance, which is key for gaming. Now let me introduce you to our top-of-the-line Ryzen 9 HX processors. The 5900HX boosts up to 4.6 gigahertz, while the 5980HX boosts up to 4.8 gigahertz, both with 8 cores and thermal design power of 45 watts or higher. So now let's take a look at the Ryzen 5900HX in action. What you're looking at here is a very graphics-intensive game, Horizon Zero Dawn, running on our new Ryzen 5900HX processor. We're running this game at 1080p with the high detail preset to really stress the CPU. And as you can see, our new mobile HX processors are delivering smooth frame rates of over 100 frames per second. And for all of you looking for a mobile 4K experience, I'm happy to report that gaming notebooks featuring our new HX processors are also capable of delivering smooth gaming experiences when running at 4K at high settings. Now turning to some benchmarks versus the competition, whether you're talking about single-threaded performance or overall CPU performance, the HX series wins by a wide margin. This is why the best gaming notebooks of 2021 will be powered by AMD Ryzen Mobile HX processors. To bring the Ryzen 5000 mobile processors to market, we're really pleased with the strong partnership with the industry's leading PC OEMs. This year, we expect the number of notebook designs powered by our new generation of Ryzen mobile processors to grow by 50% compared to the Ryzen 4000 series. We expect more than 150 ultra-thin gaming and professional notebooks powered by Ryzen 5000 series to launch this year. This means even more choice for consumers. And you won't have to wait long to get your hands on these new systems, with the first notebooks expected to be on sale from the world's top notebook providers in February. We couldn't be more excited about what the Ryzen 5000 will do for you in 2021. To drive innovation in the PC market, you need great partners. Our next guest leads one of the world's largest PC companies. Let's welcome HP CEO and a great friend, Enrique Lores. Hi, Enrique. Thank you so much for joining me today. It's great to see you to start the new year together.
Lisa, it's great to see you as well, and congratulations for keynoting this year in AMD, and also for all the success of AMD.
Well, look, we are so honored to be partnered with HP. HP has really been at the center of Silicon Valley innovation. And during the past year, you and I have talked a lot about, really the charge that you're leading in helping consumers and businesses use technology to transform the way we live, work, and learn. Can you tell us a little bit about some of the trends that you've seen accelerating over the past year?
Sure. I think one of the most important things we have seen during the last months is that PCs have become essential. With people working from home, kids learning from home, playing from home, families entertaining from home, the PC have become really the center of all these processes. And this is driving a new source of innovation, enabling people to do things from their homes, connecting to their offices, really becoming much more efficient. And this is what we all have been working together. And I think we also have learned that it's not only about developing technology. It's about developing technology that everybody can access, because I think we have an obligation as well to make sure that technology doesn't help to divide our current societies. So this is something that we are working together on that I think is very important as well.
No, I think you're absolutely right, Enrique. It's such an opportunity for us to offer technology to help people in all walks of life. So, look, I think the AMD-HP partnership has, spanned a really broad reach from commercial PCs to ultra-thin consumer notebooks to gaming and creator PCs. So we just showed everyone the new AMD Ryzen 5000 mobile processors, and we truly appreciate the deep partnership with HP. Can you tell us about some of the designs that you're planning this year?
Yes, and before that, it's probably useful to recap a bit. I still remember the first meeting you and I had when none of us were the CEOs of our companies, where we were thinking and designing the first commercial PCs with AMD. And we have really gone a long way since these very early conversations 6-7 years ago. And I think with the launches this year, we have really shown how much progress we have made. And whether we look at the versatility of the new designs, the security that we have built into the solutions, and the new form factors and the premium designs that we are bringing, clearly we are making a difference, and we are showing what the combination of both companies can bring to the market.
No, you're so right, Enrique. What I really appreciate is that every year the technology gets better, the partnership gets better, and I think our what we can offer our customers gets better. So Look, it's an incredible time for innovation in the PC market and across tech more broadly. Enrique, thank you so much for joining us today. I'm really, really thankful for our partnership and look forward to all the great new devices that we'll have out in 2021. Thank you.
Thank you, Lisa.
Now let's turn our attention to gaming. Gaming has continued to grow in recent years, and 2020 was another record year. 4 in 5 US consumers have played a video game in the past 6 months. And at $174 billion in annual revenue, the gaming industry is actually larger than the movie and music industries combined. We're now approaching 3 billion people playing games. That's 40% of the world's population. Now, gaming is at the heart of so much of what we do at AMD. Gamers push us to innovate faster because they always want more. More frames, more pixels, and more immersive experiences. Which is exactly what we delivered with our new CPUs and GPUs and the new generation of game consoles powered by AMD. The hottest products in the world today are the new game consoles from Microsoft and Sony. Panos mentioned our work with Microsoft to build high-performance CPUs and GPUs for the Xbox Series X and Series S. We're also incredibly proud of our deep partnership with Sony to power the new PlayStation 5. All these next-generation consoles use custom AMD SoCs with Ryzen and Radeon technology. Console gaming has never looked better, and AMD is providing the underlying technology pushing 4K gaming across these platforms. Now, for PC gamers, we introduced high-end graphics cards to the desktop PC market at the end of 2020 with the Radeon RX 6000 series. With the Radeon 6900 XT, 6800 XT, and 6800, we have leadership at the high end. The reviews and awards for these products have been fantastic, and we know that millions of gamers are excited about the RX 6000 series. Whether you're building your own gaming rig or buying a new gaming PC, we truly have the best for PC gamers. We're working with our partners to drive a record number of premium desktop gaming systems from OEMs and from system builders, featuring our new Radeon RX 6000 series graphics cards and our Ryzen 5000 series desktop CPUs. Now, the underlying graphics architecture for all these new PC and console products is AMD RDNA 2. With RDNA 2, we really exceeded our goals. We doubled the performance from the first generation of RDNA in 2019, and we achieved a 65% performance per watt increase while supporting the full DX12 Ultimate experience for gamers. The team did a great job with this architecture, and you'll see many more products in 2021 with RDNA 2. We talked about the importance of gaming notebooks a bit earlier, and we'll be bringing RDNA 2 to gaming notebooks next. So let me show you a preview of the RDNA 2 graphics architecture in a notebook reference design. What you're looking at here is Dirt 5, another demanding game running at ultra-high settings in 1440p. And what you see is more than 60 frames per second. Just beautiful, smooth gameplay. We're on track to launch the first notebooks with RDNA 2 in the first half of the year with our partners. And you'll also see new mainstream RDNA 2 desktop graphic card designs in the first half of the year as well. We're very excited to have RDNA 2 across the entire spectrum from consoles to desktops to notebooks soon. Now, while console and PC gaming are the most fun for some people, for others, it's gorgeous content and Hollywood films. Today, high-performance computing makes it faster and less expensive to produce amazing movies and TV shows. My next guest has overseen some of the most beloved stories and characters ever, with visual effects and computer animation powered by AMD. Francois Chardevon is the head of technology for Lucasfilm and Industrial Light and Magic.
Hi, really happy to be here, Lisa.
Great to see you. Thanks for joining us. So ILM, Lucasfilm, and AMD have worked together now for more than a decade, yet 2020 is probably one of the most memorable of the years that we've worked together. The demand for content is through the roof. Can you tell us a little bit about how 2020 has changed the way you work?
Absolutely, you're right. Lucasfilm just recently announced 10 new series and feature films, and a lot of studios are doing the same thing. The content creation is through the roof across all of the major content creators. And for ILM in particular, despite all the disruption for 2020, it's been an incredibly busy year. And we're looking out to 2021, and it's going to be even bigger. We built an entirely new studio from scratch in Sydney, Australia, to add to our 4 other studios. We opened a few months before the pandemic really hit, and it was an opportunity for rethinking from the ground up all of our infrastructure to make sure that we're making the best choices possible. One of the most important parts of our infrastructure for what we do is the render farm. really the compute firepower that creates all of the images that you see on screen. And for Sydney, we decided to go exclusively with AMD to build our facility up. And that was something that really empowered that studio to hit the ground running despite all the disruption of 2020.
Wow, Francois, that's just fascinating. I mean, just to think of all of the things that you guys have to think about when you're, producing, the best content in the world. So, you guys were really an early adopter of AMD EPYC and Threadripper. Can you tell us a little bit about how the tech works for you?
Absolutely. I mean, I think for us, it's really about scale and flexibility. Scale just to produce the sheer amount of content across all of our studios where we just need as much firepower as possible. And AMD is really focused on building out the amount of power that you can put in any individual's hands. The amount of threads and cores that you have available is unprecedented. And this really helps us deliver the content that we have. That scale comes into play a whole lot more than it ever has, even for interactive processes, not just the overnight processes, where more and more we're just seeing software take advantage of that sheer amount of threads that are available with AMD processors in a way that software never has before. And so artists are able to make changes and immediately see the results. That gives you more of an intuitive sense of how when you turn the knob, it really affects what you see on screen. That really changes how you approach the creative process.
Francois, you sound like you love cores and threads just as much as I do. So we love that. But you're really pushing the envelope on what technology can do, and it sounds like there are actually things that you can do in your creative pipeline or workflow that you weren't able to do before. Can you tell us a little bit about that?
As artists more and more are having to tackle really high resolution content, high dynamic range, more bit depth, it's just a lot of data to process. And a lot of the codecs, the compression algorithms for the content are becoming more and more elaborate than they have before. And being able to play back at speed 4K content, 8K content, we have rides that are projected on huge screens that are sometimes multiple 16K content. We've never been able to review that before. And that's an area where we're really looking to AMD to help us solve that problem in a cost-effective way that used to be really limited to specialized hardware. And AMD is making that a whole lot more commoditized than it ever has in the past.
That's fantastic. Really, really exciting stuff. I know we're all looking forward to seeing it. Well, thank you so much for joining us today and giving us, some of your insights on how, high performance computing really does enable all of the wonderful work that you do at ILM and Lucasfilm. We're really proud to be your partner and really look forward to doing much, much more together in the future.
Thank you so much, Lisa. This has been great, and AMD has been an amazing partner through all this.
Let's take a look at some of the great work by Lucasfilm and ILM using high performance computing. To share more about our work in the PC, workstation, and server markets, let's welcome our great friend, Lenovo Chairman and CEO, Yang Yuanqing. YY, it's great to see you today. Thank you so much for joining us.
Thank you, Lisa. Thank you for having me here.
I've heard you say Lenovo is focused on building smarter technology for all, data center, PCs, mobile phones, and smart devices. Can you tell me a little bit about what the Lenovo team experienced in 2020 when it comes to the world's transition to digital first?
Why some people predicted the smartphone would replace PC and tablets before. The work and the study from home trend have proven PC to be an essential productivity tool now. Although this trend was started by the pandemic, it has now become a new lifestyle. So even after the pandemic, we believe this new lifestyle will stay. And Lenovo is committed to meet our customers' requirements.
We enjoy such a great partnership that spans from data center to workstation to all forms of PC. Lenovo has some of the best solutions with AMD products, whether it's our Ryzen 5000 or our Threadripper workstation products, or our AMD EPYC product line. How do you view our expanding partnership and what we're able to bring to customers in these markets?
We are happy to address different customer needs with a broad portfolio of technologies and the solutions we create with AMD. Our leading gaming systems are well recognized by esports enthusiasts. Our yoga products are the perfect blend of style and performance. Our ThinkPad and ThinkBook allows professionals take their productivity home or anywhere. And our workstations continue to generate creative contents and inspire the world.
That's just really fantastic, YY. We're starting a new year together during our digital CES, and I know you often use CES to kick off your most important announcements for the year. So can you tell us about some of the things that you're excited about for 2021?
As part of our smarter technology for all vision, we believe there should also be connectivity for all. We have embedded 5G technology across a number of our products to make sure they can be always on and always connected. But 2020 told us that what our customers need in the new normal is a breakthrough in a few existing technologies that have become absolutely essential today. We are leveraging advanced technology like artificial intelligence and the latest hardware innovations to drive breakthrough in this space. As a customer-centric company, Lenovo is definitely focused on innovations that makes the biggest impact on customers' lives today and in the future.
That sounds super exciting, YY. Thank you again for joining us today. I'm really looking forward to all the great new AMD-powered products Lenovo has in the works. We've talked about the impact of high-performance computing in our research, in our work, in education, gaming, and the movies. But high-performance computing is also changing the world of professional sports. AMD is very proud to be an official partner to the 7-time champion Mercedes-AMG Formula One racing team. Now let's talk to our superstar driver Lewis Hamilton and team CEO Toto Wolff to find out how the world of high-performance computing and auto racing and esports are coming together. Lewis, how are you? It's so great to see you after such a busy year.
I'm well, thank you. Thanks so much for having me.
Well, look, first, congratulations on your record-tying 7th Formula One Drivers' Championship. Just simply amazing. Toto, thanks for joining us, and congratulations to you as well for winning your 7th Constructors' Championship as a team.
Thank you for having me. I'm pleased to join you. And yeah, it was another good season. We won a 7th Constructor Championship. It was a difficult year with COVID-19, but finally on track, we were successful.
Oh, that's fantastic. I know it was such a grueling year, but you guys were just amazing. And hey, one of the things I know about you is that you love gaming, and AMD loves gaming too. In fact, I heard you might be having some fun in your downtime with your new AMD-powered Sony PlayStation 5.
Yes, absolutely. Yeah, I've actually always been. My dad was actually. He was always into computers, and when I was younger, when we started racing, he worked on computers for the British Rail, and then he got into his own IT and network support company. So I remember being at home growing up, and my dad taking apart these the PCs, and I remember getting involved and learning how to build computers for him when I started working with him when I was 17. I was always into gaming, and watching the technology advance over the years has been absolutely mind-blowing. And yes, of course, I've been nagging everyone for the PS5 like everyone is, and I finally got it, and I actually carry it around with me. I travel with it everywhere I go, and I have a real gaming monitor, the whole headphones. I'm fully geared up.
I'm just imagining you getting into the zone with your PS5, so that's wonderful. Look, one of the reasons AMD is an official partner to your team is that Formula One is such a great application of high-performance computing technology. Can you just tell me a little bit about your view of the role of technology in racing and how the team depends on partners like our computing technology?
Well, it's incredible when people look at the image next to you of the Formula One car. Everything is built in-house. Pretty much everything is built in-house. give or take the tires and maybe brakes, but majority of the stuff is designed in-house and built in-house and designed on CAD machines. We, the technology in terms of the software they use for aero data analysis. We have a real wind tunnel, and then we have a virtual wind tunnel, and the crazy amount of computing power that takes place for that is insane to see, and it's advancing all the time. And from each weekend there's a huge amount of download. I think it's over 500 gigabytes of downloaded data, which gets transferred back to the UK to headquarters, is digested. We're running a huge amount of simulations through the weekends in terms of getting the right setup, strategy. From a driver's point of view, to get ahead, you need to understand the data. That's understanding all the controls. I have over 20 buttons on my steering wheel that have a direct link to how the car behaves. So I'm studying that in the background on computers all the time. And also when we come back into the garage, the car downloads and the data pops up on my screen, and I'm having to push that technology to be faster. The faster we can get that, the faster I can analyze it, and the faster I can get back out there and improve. So it's a huge part and huge asset for us, and I'm super grateful that we have AMD with us.
Oh, it'll be fantastic to watch. We're looking forward to it. So our work with you and the team goes much deeper than seeing the AMD brand on the beautiful W11 car. From the computing needed to design the setup and set up the cars, to the notebooks and desktops that the team uses on track and everywhere in between. Can you talk a little bit about how you're using our technology as a team?
Yes, so it goes much beyond the sticker on the car, like we call it. The marketing and branding benefit is just the icing on the cake. What is really beneficial in our relationship, and there's only a few of these partnerships that we have, is the technical collaboration and the advantage that you provide to us. And it's not only hardware like the desktops or the notebooks, it's really ingrained, or it's making its way into our performance departments, be it in the vehicle dynamic group or in aerodynamics into the simulation. We are starting to really integrate AMD products, and that should give us an advantage against our direct competitors.
Well, we'd love to be part of that advantage. And now, Toto, you're responsible for not just the Formula One team, but the Formula E team, as well as the esports team. And I know many of our viewers here are very interested in esports. So can you talk a little bit about how you're using technology there?
We have been growing our department around esports from something that was a little bit trial and error a few years ago to a real professional team. And we see the audiences growing massively, and it has become an area of performance, like with the real car. So it's all about simulation, it's about development and the setup of the car. And there, again, without wanting to disclose our competitive advantage, you have been part of our success, and we count on you.
That's super, super cool. Louis and Toto, thank you so much. It's been such an honor to have you join us today. And best of luck in the new season. I'm really looking forward to our partnership continuing and seeing what happens as we go through the year. Yes,
we are really happy and proud to have you on board. And you help us with the competitive edge. And yes, thank you very much for having me.
Now let's turn our attention to one of the most important areas of high-performance computing, the data center, cloud, and supercomputing. During our 2019 CES keynote, we demonstrated the world's first 64-core x86 server processor. Since then, AMD EPYC processors have been adopted by the largest cloud service providers, the fastest supercomputers, and in the heart of the enterprise. In addition to the researchers we heard from earlier using AMD technologies for medical research, our EPYC processors are also being used for research in areas like weather forecasting, climate change, and energy exploration. From AWS to Google to Microsoft, Tencent Cloud, and Oracle, The largest cloud providers have adopted EPYC processors to power their internal infrastructure and services. And that incredible growth in video collaboration I highlighted earlier, those too are powered by AMD EPYC, including services like Microsoft Teams running on Azure. And while each of these customers has unique needs and requirements, they all share one thing in common. They will take as much computing power as they can get, and they all want more. That's why we're so excited about our upcoming 3rd Gen EPYC processors. 3rd Gen EPYC will reset the bar for data center computing. With up to 64 leadership Zen 3 cores, our next generation server processors extend our leadership in performance, total cost of ownership, and security. But today, we wanted to give you the world's first preview of the upcoming processors, codenamed Milan, running WRF, one of the most popular tools used for climate research and weather forecasting. WRF is used in 185 countries, and as you might expect, to simulate something as complex as a weather system, WRF is an extremely demanding application that benefits from more processing power. Let's take a look at the competitive performance of our upcoming Milan processors running a simulation. In this test, we're comparing 2 comparably configured servers running a compute-intensive weather forecast for the continental United States. The system on the right features 2 of our next-generation 32-core Milan processors, and the system on the left features 2 of the highest-end dual-socket processors from our competition. We're taking in a large set of climate data to produce a 6-hour weather forecast, and what you see is that the additional performance of the AMD EPYC processors completes the simulation much, much faster. The 3rd Gen EPYC server completed the forecast 68% faster than the competition. And the speed to complete in this case is very important because if the simulation runs faster, it means scientists improve the accuracy of the forecast by using a larger data set for the model or running more simulations per day. Now, just imagine how much more performance you're going to see with 2 64-core Milan processors. We're extremely excited about bringing 3rd Gen EPYC to market and can't wait to show you more when we launch later this quarter. Now, it's been so much fun today, but it's time to wrap this up. I'm so thankful for our amazing partners who joined us today. Panos Panay from Microsoft, Enrique Lores from HP, Francois Chardavoine from Lucasfilm ILM, YY from Lenovo, and Lewis Hamilton and Toto Wolff from Mercedes-AMG Formula One. Today, we've seen the power of high-performance computing, from scientific research to education to global business to auto racing to gaming and filmmaking. I hope you're leaving with the same excitement that I have. I'm really proud to be part of this amazing industry, and when we work together across disciplines, the technology that we build can make a huge impact on people's lives. AMD and our partners will continue to push the envelope on high-performance computing in 2021 and the years ahead. Thank you for joining me today, and have a fantastic digital CES experience.
Welcome, folks. I am Chris Schott. I'm the host of Engadget's Explainer Show, Upscaled on YouTube. And kind of my secret is I pretty much started this show as an excuse to get to talk to really smart people about the work they were doing and to try my best to understand it. And in that spirit today, I am joined here by Intel's Dr. Rich Uhlig, who is the director of Intel Labs, which is a division in Intel which is doing some really crazy, impressive work. Now, Rich, maybe you can actually just give us a little introduction about what Intel Labs' mission is. I'm not sure it's a part of the company that people are familiar with. I know everyone knows Intel for your processor designs and all the work in computing, but what does Intel Labs itself specifically focus on?
Yeah, happy to talk about that, Chris, and thanks for having me on. It's I'm delighted to be part of this event. So, Intel Labs is the research organization for Intel, and our primary purpose essentially is to explore the future for Intel. And we use a number of different methods for doing that. We engage with academic researchers. We do our own original research within the company. And we work closely with our business unit partners and product team partners inside the company to take our research innovations and translate them into a form that Intel can ultimately bring to market at scale. So that's essentially what we do.
So I want to dig into the specifics of some of your research in a second here, but how do you decide what avenues of research are worth exploring?
Well, we use a number of different criteria, and it's not so much about the time scale, whether it's far out in time or near in, but rather we look for pain points, areas where there's something that makes computing difficult for people to engage with, or sometimes we'll look for some emerging barrier that's coming. It might have to do with power or some limiter to being able to do something new with computing, and sometimes we look for enablers that will technologies that make entirely new things possible. And so just to give some examples, several years ago within the labs, we observed that one of the pain points with working with PCs was this abundance of different kinds of connector types, that the sides of PCs were littered with. And our concept was that we should try to converge all of them onto a single I/O protocol, and that's what ultimately became Thunderbolt and USB Type-C. So that would be an example of an innovation that started in the labs. But we've done similar things, like when we recognized that there was a lot of computing capability available in our server systems, and oftentimes it wasn't fully utilized. We invented virtualization technology and brought that to market, and that's been widely adopted in the cloud by cloud service providers. And that would be another example of a technology that came out of the labs. And maybe one that we could talk a little bit more about today is our work in silicon photonics, which is all about identifying a limiter, a limit to how much we can deliver I/O to compute devices. And silicon photonics is all about overcoming that limit.
Yeah, so I know this is one of your particular areas of interest, I know. So this is probably not a field that folks are particularly familiar with. You just want to give us kind of the general overview about what this technology is. You said it's trying to get through bottlenecks in I/O. So we're talking about like feeding data into the chip faster.
Yeah, that's exactly right, Chris. So if you think about, what we need from like a high performance compute device, whether it be a high-end server CPU, or it might be a GPU, or maybe an FPGA, that you have to feed it data. And as it gets more and more capable in terms of the amount of compute that it can do, the amount of data to feed the beast just increases over time. And one of the things that we've identified as an impending barrier to making further progress is that just the amount of power budget that goes to I/O, just getting the data onto the chip, is taking an increasingly larger proportion of the available budget that you have. And that means that you're increasingly, we're not leaving power for the compute itself. And a lot of that has to do with the limits of electrical signaling. The amount of data that you can push over electrical links is getting increasingly limited, and it's getting harder and harder to do, especially at larger distances. And so we think that there's a very exciting opportunity around moving from electrical signaling to optical communication. And we've been developing in the labs a lot of different technologies that allow you to go end to end with optical interconnect straight into a CPU or a GPU package.
So when we're talking about the current kind of electrical interconnects, that's the systems like PCI Express or things like that people are now using to hook memory and graphics into the processor?
Yeah, that's right. I mean, the predominant form of communication in computing systems today is electrical signaling. It's the more cost effective. It's brought us a long way over many decades of improvement. But what we're starting to see is that the ability to deliver high bandwidth electrical links is getting limited, especially at distance. And so what you've already begun to see in data centers is that the different servers between racks are getting connected through optical links. And what we think is going to happen over time is that those optical links are going to get closer and closer to the individual compute nodes and the different compute packages as well. And so in the labs, we've been developing technologies that allow us to integrate those optical links straight into the compute package.
So we're talking about right now in data centers, you've got the racks maybe hooked together with fiber optic cable, and you're talking about actually building an optical link maybe directly into the server, inside of an individual server itself for moving data between the different parts.
You got it. That's exactly the vision. And to make that possible, we've had to invent a number of different new components so that deeper integration into the compute package is possible. There's when you think about what you have to do end to end for optical links, you have to have, first of all, a source of light. And so we've actually, going back many years in the labs, have developed technologies around what's called a hybrid silicon laser, where we can generate light through silicon devices. Once you can do that, you have to be able to modulate data signals onto those optical signals over different wavelengths of light. You need ways of guiding that light from endpoint to endpoint. You need ways of amplifying that light. You need ways of detecting the light at the other end. And so there's a number of different components and physics behind implementing each of those that we've been investigating in the labs. And
so in the current fiber optics I've seen, like the ports for connecting in, I've not spent a lot of time in servers, but I've at least seen fiber optics links used in PCs and the like. And I mean, we're talking about like a fairly chunky plug that usually goes in the back of a port, and then kind of a hefty cable that strings to the next port. What level of miniaturization? Oh, we have lost Rich here for a sec. We're going to attempt to get him back online.
I am back. Can you hear me?
I can hear you.
All right. I guess we just lost the link there momentarily. I'm not sure where you lost me, but I can. I think we're in the middle of talking about
building this all kind of into the different parts you needed to build this into an actual board. I was just wondering, so what how different is this from the? I mean, I've seen the sort of fiber optic connectors used in servers, and a lot of them are a pretty chunky port. I mean, maybe the size almost of like a Sharpie marker. So what scale of miniaturization are we talking about to bring this down to the level you're talking about with doing this like on a compute package?
Yeah, you're right that today's optical transceivers, they are still discrete devices. They're larger in dimension and part of the reason why that's the case is that until recently, we haven't figured out how to modulate electrical signals onto the optical link with devices of small dimension. And when I say small dimension, something that's small enough that you could situate it right next to the compute package And we've developed what are called micro ring modulators that you can have as many as 100 of them arrayed around the compute package, and therefore you have the option of integrating it straight into the compute package. And what that means then physically is that you take the electrical link that would otherwise be required at each endpoint of an optical fiber, which is really sort of the last inch or so that you need to remove in order to achieve this vision of really energy efficient, high bandwidth communication at distance.
So we're talking about actually integrating tiny optical fibers onto the chips or boards themselves to form these connections.
That's right. Yep, you got it.
So one thing, when I was researching this, one thing I thought was really interesting is just the idea of how the modulation works with these ring structures. For folks who maybe are not following all of this, modulation, we're talking about kind of turning the signal, the light beam, into a pattern that actually carries data. And it doesn't work in the way that I thought it would. I think in my mind, I assumed you'd just be sort of like turning a flashlight on and off, essentially, to get this this light signal with your ones and zeros. But it's a little more complicated than that, it turns out. Do you want to talk through how this works with these ring structures?
Sure. There's a few different components that are coming together. To start, you've got the electronics within the compute device that are ready to send data across the package pins. And you're still in the electrical domain at that point. And you've got ones and zeros that are the data that you want to send off of the chip. Now, you also have a light source, this hybrid integrated laser that's ready to generate light at different wavelengths and send onto an optical fiber. And what you need to do is cross that boundary between the electrical domain to the optical domain, and that's achieved by what are called micro ring modulators that are tuned to certain resonant frequencies so that they can generate light at specific wavelengths that are sent onto the optical fiber, and they're coupled to the data signals that are generated on the sending side of the link. And what's really amazing about optical technology is that you can have multiple different wavelengths that all share the same optical fiber, which means that you can get much higher density of communication through a single link, something that would otherwise, with electrical signaling, require a whole bunch of package pins and wires coming off of the chip.
You're talking about, I realize the frequencies are maybe not quite the same, but essentially like shining a bunch of different colored lights down a fiber simultaneously, and they can be picked apart and each one can carry its own signal.
That's right. They're multiplexed onto the same fiber on the sending side, and then they're teased apart on the receiving side so that you reconstruct the signal. And so you get a very efficient use of that fiber. And also, a really important part of optical is that you can do so at distance. You can begin to separate the receiver and the transmitter by large distances, and that is also a distinguishing factor of optical communication compared to electrical links.
Yeah, what is is there an example of what the performance difference is there over distance? I know, a lot of USB cables and the like that we work with in the non-server consumer world tend to max out at not terribly long. But what's possible with optical fiber here?
Yeah, so once you account for the fact that you can get greater distance with optical, and that's an important property. What happens with electrical links is that as you get, you can still push higher bandwidths, but you need to go to shorter and shorter distances, and that's one of the limiters. But after that, there's different ways of thinking about performance. One is the efficiency of the link. So how much energy is required to transmit the bits of information. And so if you look at sort of best in class Ethernet style communication where you're communicating at distances, you might be in the tens of what are measured in picojoules per bit. Something like 28, 30 picojoules per bit for a long distance communication. We think that with the right
Just to clarify, the picojoules per bit, that's essentially electricity per data moved. That's what we're looking at?
Yeah, it's the amount of energy. Those are the joules are a measurement of energy to transmit a bit of information, and so you want that number to be as small as possible. The smaller it can be, the more data you're able to push over the link. And so currently, with optical communications, you do have to spend a fair amount of energy to get the bits pushed across the optical link. But through some of the innovations that I was describing earlier, we believe that we can improve that by an order of magnitude or more. And so that's one way of thinking about performance, is how much energy is required to send the bits. Another way of thinking about it is what you could call bandwidth density. So this is how much space do you need in order to push data off of the chip. And one of the problems that we have with electrical links today is that we have to add more and more pins to the package in order to reach higher data rates. But because of the property that I described about optical before, where we can multiplex multiple different colors or wavelengths of light onto the same optical link, we can get much higher bandwidth density. And there we think we can get 20, 40x kinds of improvements. And you can get we want to get north of a terabit per second of bandwidth within a millimeter of shoreline around the chip package.
So we're talking a terabit of data moved per second in and out of a chip?
out of a chip over a millimeter worth of shoreline on the chip. So we think we can even push that higher by aggregating more and more links, optical links onto the package. But you can see that you have, much more headroom for improvement with this optical technology than you would have with electrical. And that's what has us so excited about it. And we think it will really change the way that computing systems are built, because you can begin to disaggregate the different things that we think of as servers in new ways. You can separate compute from storage and memory, and you can begin to assemble systems in entirely new ways that will lead to all kinds of improvements in performance and efficiency.
So what are the odds this filters down to my SSD some point 15 years in the future, or is this mostly a high performance computing innovation we're looking at?
Well, it's probably a high performance computing innovation in the near term. But a lot of that has to do with the fact that we still have to get the cost down. And high performance applications can tolerate higher costs. However, I mentioned earlier Thunderbolt technology. In our original vision of that was going to be an optical link. In order to, even in client applications. And so ultimately we went with electrical signaling for Thunderbolt. But there's you can imagine a future where even in client applications where you're, multiplexing multiple I/O protocols at between a PC and then the peripherals that you want to connect to, if you have need for higher bandwidth, then you could imagine moving to optical links in the future, and there could be client applications as well. So it's something that would be enabled once we can bring the costs down.
That's pretty cool. I look forward to being able to connect in my external hard drives via a terabit a second link. I wanted to jump to one of the other areas that you folks have been working on at labs. One that I don't know if it's a super common area of knowledge with our general audience, but neuromorphic computing, which has a heck of a name here. Can you give us a little introduction about what this project is, what neuromorphic computing is, and what you're hoping it can do?
Yeah, sure. Let me just start by defining the term. So, the name is just suggestive of the idea that if you look at biological brains, they are an amazing thing, what they're able to do. And if you think about neurobiology, we believe that there's much that you can learn from that. And so we're considering how we can take lessons from biology, from biological brains, and build computing devices that take the form, or at least mimic some of the dynamics of this kind of intelligence. And really, it's inspired by or recognizing that there's been tremendous progress in AI. We've all seen that in the last several years, and it's based on a model of artificial neural networks that really abstract away the some of the more subtle nuances and behaviors of biological neurosystems. What we want to do with the neuromorphic computing is capture some of those dynamics. In particular, what we see in biological brains, where you have many neurons that are interconnected in a dense network, and any given neuron may fire based on the inputs that it receives over its synapses, and each neuron is then connected to other neurons, and they can send what are called spiking messages to those other neurons in the network, and then excite one another. And so this dense interconnection of neurons is what happens in biological brains, and we're trying to model some of those dynamics so that we can see if we can build a system that exhibits some of those same qualities. And just to underscore the point, by way of analogy, if you look at something like a cockatiel, it has a tiny little brain, but it's able to do amazing things, navigate very complex physical environments. Cockatiels can even learn words and sort of parrot them out. They can even turn objects into tools. So there's a lot that can be done in a very small brain of an animal. And we're way far away from that when you think about the compute that goes into, say, a drone, where it's going to be many orders of magnitude more power that's consumed. The capabilities of being able to navigate an environment are much more limited. And so we know that it's possible. There's an existence proof with biological brains. And so what we're trying to do with neuromorphic computing is capture the essence of that and see if we can't solve some of those problems and build more efficient, intelligent systems.
So what are these neuromorphic chips or neuromorphic processors? What are they suited for? I guess what's the advantage that they're able to provide? I know it's still relatively early days, but what can they do, I guess?
Yeah, no, great question. So, we're looking at them for a few different classes of applications. The first is the things that I just talked about. We think that they have some promise in building the control systems for robots or drones. If we think about biological brains, that's what they're really good for. If you're an animal out in the wild, being able to navigate a complex, dynamically changing environment is something that you can do with high efficiency. And so there's an analogy there in building robotic systems where we could potentially use it for a control system for, say, a drone or for a robot, and to do things that biological systems do. Things like building systems that can learn how to smell. Taking like the inputs from a chemical sensor and then recognizing what the scent is in the same way that that we can discern what's in an environment when we take in those inputs through our noses. We're using it to build systems that can touch, make sense of tactile sensors that may be built into a robotic arm. So there's a whole class of applications that are in that space. But what's interesting about neuromorphic is that it's also very energy efficient, and we think therefore that it can also be used for other classes of problems. And when we build our neuromorphic computing systems, we're not only building small single node implementations, but we're also building larger clusters of neuromorphic systems where we scale up to a really large number of simulated neurons. And we think that there are problems in the space of constraint satisfaction, for example. Like if you think of Sudoku, that's solving a Sudoku puzzle is a constraint satisfaction problem. But there's many other optimization problems that are like that. And neuromorphic systems seem to be really good at that kind of an application. Another application would be solving problems in similarity search. So imagine you've got like a really large visual database of images, and you want to find, and you've got a source image that you would like to submit into that database, and you'd like to find all the other images that look like it. Like let's say you've got a picture of a couch, and you want to find all the other pictures in your visual database that look like a couch. That's called similarity search, and that's something that neuromorphic systems are pretty good at. And if you think about it, there's an analogy there too, that once we with biological brains build a sort of a memory of different kinds of visual imagery, and so when we match against a new sensory input that we get, we're able to make that linkage between a past experience and a new experience. So those are the kinds of things that we're exploring with our neuromorphic prototypes.
So is it fair to say that like a lot of the neural network and deep learning algorithms that have been used in AI work for the past while are kind of doing the software simulation level of how a brain structure might work, and this is trying to actually build some of that into the actual processor design itself?
Yeah, at a high level, I think it's a fair characterization. If you look at artificial neural networks, or what are known as DNNs, they are abstracting away some of the dynamics that we see in biological brains, and that those temporal dynamics, what we see with spiking messages in a neural network, in what's called an SNN, a spiking neural network, is the additional thing, or the differentiating thing. And we think that by capturing these additional dynamics, we'll be able to get new forms of efficiency. And we're also hoping that we'll be able to build systems that can learn on the fly. Because if you look at a lot of DNN designs, deep neural networks, they tend to operate in two modes. There's a mode where you train against a labeled data set, and you learn how to train the weights of the neural network, and then you deploy it, and then you can use it for recognition and classification tasks. But it's really a sort of a bimodal sort of mode of operation. With neuromorphic systems, we want to both get efficiency and be able to learn on the fly. And that's one of the things that we're exploring with this research.
So do these chips have to be designed kind of in concert with the learning algorithms that are actually going to run on them? There are like a normal processor may not be terribly efficient, but there are a lot of different AI models you could run on one. Are these kind of built in concert with the software that emulates these neural networks, or how does that designing work there?
Mm-hmm. Great question. In the same way that we design classical computers so that they can be programmed, we're doing the same thing with our neuromorphic designs. So we have a single design, and you can sort of think of it as an efficient implementation of the dynamics that we see in biological brains. But it actually doesn't look like a biological brain. It really is a bunch of cores with an on-die fabric that is able to connect those, what we call neuromorphic cores, and those neuromorphic cores are simulating what a neuron would do. And any given neuromorphic core can model a bunch of virtual neurons that can receive inputs and generate outputs, these spiking messages that I described earlier. And what we do to program this is we have a software stack, a layer that runs on top of the architecture that allows a programmer to express what they would like any given virtual neuron to do. So we have these things that we call firing rules, and it's just an expression of what are the conditions under which a virtual neuron will generate a message into the network. And that's how you program a neuromorphic system. And so through that flexibility of defining those firing rules, you can solve lots of different kinds of applications. And that's really how we're beginning to do these explorations. And I should say a little bit about how our methodology and how we do this. So at Intel Labs, we believe really strongly in collaborating outside of the company. And one of the things that we've done is set up a network of neuromorphic computing researchers outside of the company. And by the way, this is a field that's been ongoing for many years now. But what we're doing is enabling it with these prototypes of neuromorphic chips. We have a system that we call Loihi, which is a neuromorphic implementation that we've put in the hands of these external researchers. And we've also enabled them with software that allows them to express their algorithms, applications that they think may be of interest and useful to explore. And that's how we're beginning to learn what kinds of problems this style of computing will be good at.
That makes a lot of sense. And the chips you're making, the Loihi, is this built? It's the secret's just in how it's organized. Is this built like one of your other, just like an Intel processor, or does this take some special fabrication technology to actually assemble?
It doesn't require a special process. In fact, the Loihi design was just implemented on our 14 nanometer process. It uses regular digital logic. It's not exotic in that sense. There are some kinds of neuromorphic designs that are based on analog computing principles, but it's still a digital design. One thing that's unique about it is that it's using a different kind of design methodology, what's called asynchronous design, which is a way to get some additional efficiency without depending on a synchronous clock for that drives the advancement of the computation. But aside from that, the innovation in the design has to do with how we've built a system that's able to model the dynamics of a neuromorphic system and how you program it in the manner that I described earlier, and that's where we think the efficiency is going to be coming from.
That's very cool. So yeah, retool. It's still transistors and memory and everything, but it's the secret sauce is the organization, how it's all structured. That's very cool.
That's right. Yeah, exactly.
Where I'm taking too long. These are far too interesting topics. So I want to actually move on to another one of the things that that I've seen you folks are working on. This one is I have done the bare minimum of coding in my life, but I'm not a programmer. This one felt like it was at kind of the absolute leading edge of my ability to understand. But machine programming. Can you give us a little intro about what this topic is? This one was a little confusing for me. I got to be honest.
Okay, sure. Let me just motivate the problem. So, at Intel, we're primarily a hardware vendor. Obviously, we build our business on building all kinds of compute devices and communication devices, and we're very dependent on a really rich and capable ecosystem of software developers. We do our own software development too, but we really need lots of people able to program computing systems. And what we've observed is that it's getting increasingly difficult to program computing systems, especially as they get more and more complex. And we have this idea of a notion of a ninja programmer. This is someone that's like really good at getting the ultimate performance out of a computing system. And the problem is that there aren't many ninja programmers to go around for the kinds of, the magnitude of problems that we'd like to solve. And in fact, while we're getting more and more programmers, those programmers are emphasizing approaches to programming that increase productivity. So they're using, languages like Python in order to quickly develop code, but it's not necessarily the highest performing code that gets the most out of the underlying hardware. And so we considered that to be a problem at Intel, and we wanted to bring some technologies to bear. And the basic idea of machine programming is to teach computers how to program themselves. That's literally what the idea is. And you can take this apart in different ways. I mean, the grand vision is we'd like anybody, whether they're a programmer or not, to be able to express their intent and have a computing system do that. That's like at the highest level what we would like to achieve. And then you stop thinking about being a programmer or a coder. You just you express your intent and you get what you want out of the system. Now, that's kind of abstract and high level. And so in the labs, we really like to get concrete and make forward progress. And so a near-term vision is that we're trying to develop technologies that just make programming more efficient. As an example, a lot of time today goes not just in writing code, but in debugging it, making sure that it's correct, finding the errors in the code. And so we've been developing some new systems that are able to find errors in code automatically. And they do so by scanning lots of examples of code and then using an understanding of what good examples of correct code look like in order to find errors in code as it's getting written, and to do so automatically. And we hope that this will sort of dramatically lower the amount of time that's spent in debugging software.
So if one of the issues is that a lot of software, even written by good developers, has bugs in it, how do you pick what you're training the system on? Is someone having to go through and write stuff that you can verify and debug and know to be valid? Or how? I guess it does seem like such a widespread problem. I understand the scale of the issue, but because of that, it feels like finding appropriate training data to feed into the system would be very challenging. So how do you approach that part of the problem here?
Yeah, right. I mean, you're asking a really great question. How can you be sure that you aren't feeding the system, code that's buggy? And then if you're doing that, then how can you trust what you're getting out of it? And the short answer to that is you can't be sure that you aren't feeding the system buggy data. But you can. That doesn't have to stop you in making progress. And so, basically, what we're using is a method that's known as anomaly detection. And we sort of break the process into two steps. The first is that we point the system at a lot of examples of code, like billions of lines of production code that's out there. It's actual operating software, and so it's got to be working correctly at some level, although it may have bugs in it, right? But what we do is we just sort of mine all of that existing production code for patterns. And there are distinct patterns that you can find in properly functioning code. And you can use machine learning methods for that. You can also use other forms of analysis, formal methods for understanding the structure of code. And does it look like it's a good example, a pattern of correct code? And most correctly functioning code will fall into certain distinguishable patterns, and that's what you would expect. Anomaly detection is about finding those outliers, like snippets of code that don't seem to follow a common pattern. And it's sort of like a probabilistic approach to finding where bugs might lie. And that's sort of the second part of the process, which is scanning. So scanning all of the code that the new code that you're trying to debug, and trying to identify the places where it deviates. It has anomalous structure compared to lots of examples of production code. And that, while it still requires a human in the loop to go and look at violations, pattern violations, to confirm that there is in fact a bug, you can take a lot of the work out of it by doing this automatically. And that's the basic idea that we have. We have a system we call Control Flag that we've been recently publishing some papers on, and it's actually been able to successfully find bugs in code that had been latent for many years and were only discovered by the system.
That's very cool. It's almost enough to make me want to try to learn some more Python, I've got to say. So maybe not in the near term. Well, I know we'd put quantum computing in the title of this, but I think we're actually reaching the end of our time here, so we might have to save that for another chat in the future, though I know Intel's doing a lot of work there as well. But thank you so much for taking the time here this morning to talk to us. This stuff is all super interesting. I know we could have spent probably an hour on any one of these topics, but it's great to get an overview of all the work that Intel Labs is doing. So yeah, thank you so much for joining.
Yeah, and happy to come back at any time.
I appreciate it. Yeah, we may give you a call for some future upscales for some some research into some of these. This has been great. Thank you, folks, for watching. Stick around. We've got a short break, and then we are back. Our editor, Sherilyn Lowe, will be sitting down with Microsoft for our next interview here, so stay tuned for that.